Today, as many of us know, is the International Water Day. This year, the United Nations had as a main theme, Water for Peace. And if you allow me, I will read a couple of words from the United Nations website. World Water Day 2024 is about working together to balance everyone's needs with the dedication to ensure no one is left behind, to make water a catalyst for a more peaceful world. In this context, the first day of our exploratory workshop will be dedicated to water technologies, to water cleaning, to works related to the removal of emerging pollutants and other works in this area. So our first invited speaker for the day is Dr. Corina Bradu, graduate of the Faculty of Chemistry in 1992, University of Bucharest, is currently a professor at the Faculty of Biology and PhD supervisor at the Doctoral School of Ecology of the same university. During her career, she actively contributed to the development of interdisciplinary bachelor's and master's programs in the field of environmental protection and sustainable development. Dr. Bradu's research activity is mainly directed towards the development of water treatment and purification methods in order to find effective solutions for the elimination of priority and emerging pollutants from water sources with complex contamination. The results obtained from the research carried out within the Research Center of Environmental Protection and Waste Recovery, PROTMED, which she coordinates, are validated by a series of publications, ISI articles, and chapters, patents, and technologies applied at pilot scale. As a personal note, the group practically established by Professor Udrea, which now Professor Bradu coordinates, was a great teaching group for us. We are working together for about 20 years right now. And together we have implemented several research projects, both applied and pre-industrial projects. So today, Professor Bradu will present her experience in the field of water treatment.
Good morning, everyone. Thank you a lot for the introduction. And I'd like also to thank you to inviting me today. It's an honor to me to be here in front of you and present some of our works in the field of water and wastewater treatment. Dr. Ferescu say, we work, our, let's say, principal research direction is in water treatment, and our results obtained together with many partners, including ICECHIM teams, Radu Ferescu and Andrei Sârbu, and also the group of Institute of Physical Chemistry, Plasma and Laser, and other institutions from Romania or from other countries, for example, France.
So thank you once again, Corina. We'll go now to our contributions. In order to chair the session, I will invite my colleague Ana Maria Gurban.
Thank you. Welcome for the second day of the NeXT-Chem Symposium. Welcome for the online participants and also for the physical one. And congratulations that you are also together with us today. I have to remind you that there are some prizes, so we'll be very, very careful with your presentation and not only. I will invite now Maria Grapin to present the work study on photocatalytic degradation of some reactive dyes under visible light using hybrid iron titanium oxide systems.
Hello everyone and welcome. My name is Maria Grapin. I'm a research assistant in team number 10, and today I will going to present you my study entitled Study on Photocatalytic Degradation of Some Basic Dyes using titanium dioxide doped with iron oxide systems under visible light. The rapid progress of global industry has led to environmental pollution, and in particular to wastewater generated from aqueous effluents. containing different organic diesters, and by their decomposition are able to form highly toxic and carcinogenic compounds. The abundance of non-biodegradable and toxic dyes in aqueous effluents led to their inefficiency of their removal using conventional methods. Advanced oxidation processes can solve this problem by creating reactive species following solar irradiation, which is a sustainable and efficient technology for removing non-biodegradable dyes. Therefore, the aim of this work is to examine the photocatalytic degradation of some reactive dyes using titanium dioxide doped with iron oxide systems as photocatalytic degradation for dyes. Starting with the principles of the photocatalysis, Figure 1 shows a schematic illustration of the electron gap pair generation for undoped titanium dioxide and titanium dioxide doped with the iron product. In this study, we use titanium dioxide as a photocatalyst due to its high level of activity in many photocatalytic reaction systems. Doping with iron could include much more oxygen vacancies and vacancies which favors the absorption of water and formation of hydroxyl radicals. Iron oxide can act also as recombination centers due to the electron gap pairs when their concentration is high, according to the reactions on this slide. The schematic process for synthesis of metal oxide photocatalyst is shown in Figure 3. Titanium dioxide, sodium carbonate, and iron ions were dissolved in the solvent, the mixture being stirred well dispersed. The photocatalyst synthesis was carried out in a discovered 2.0 microwave flow reactor at 116 degrees Celsius for 10 minutes. Following the reaction, the mixture being stirred well dispersed, following by a filtering and drying stage to obtain metal oxide photocatalyst. Physical preparation for obtaining titanium dioxide doped with iron oxide by wet griding is present in Figure 2. In order to determine which method of obtaining is more effective, 3 samples were performed as shown in Table 1. For the photocatalytic degradation, it was carried out using some basic reactive dyes, such as Dreamaren yellow, color index 176, and Dreamaren red, color index 124. The paint formulation was provided by King Color. For this purpose, the photocatalysts were mixed with a styrene film-forming material and deposed on glass plates. The photocatalytic activity was evaluated by xenotest lamp for 319 minutes. In terms of results and discussion, Figure 5 presents some images of titanium dioxide doped with iron nanoparticles, synthesized with ethylene glycol in Figure A, with water in Figure B, and by wet griding in Figure C. From chemical synthesis, the photocatalyst nanoparticle formed were highly agglomerated, and they are also visible in spherical shape with clamped distributions. During a mechanical synthesis, the photocatalyst nanoparticle formed were uniformly incorporated on iron oxide surface, as shown by EDX analysis. The beta analysis indicates that the titanium dioxide doped with iron oxide obtained through wet griding exhibits a smaller specific surface area due to the nanometric titanium dioxide and micrometric iron oxide particles. During chemical synthesis, nanometric particles were employed, causing iron oxide to precipitate on titanium dioxide surface. The FTIR spectrum before and after photocatalytic tests are present in Figure 7, respectively Figure 8. It was found from the spectra that the patterns are almost identical for both synthesis samples. From the diffuse reflection spectra, it can be observed that 2 photocatalysts are visible only in the wet ground mixtures. In the case of the other mixtures, titanium dioxide practically does not exist. It confirms the fact that iron oxide is precipitated on titanium dioxide surface. The photocatalytic styrene acrylic coating were comparatively tested for the degradation of reactive dyes under visible light radiation. Experimental data suggest that the photocatalytic activity is essentially increased due to the processes that are generated at the surface of titanium dioxide. However, coating obtained by wet gilding is decreased the reactive dyes more effectively than the reverse coating, about 1.3 times faster than the coating synthesis with water, and about 2.3 times faster than coating synthesis with ethylene glycol. In conclusions, new photocatalytic nanocomposites were prepared by a simple chemical process of iron oxide generation at the surface of titanium dioxide nanoparticles by hydrolysis of iron chloride at microwave and by wet milling of iron oxide with titanium dioxide mixtures. All the mixtures were evaluated by, for structural, morphologic, textural, and optical properties. Performance of the composites were evaluated comparatively in photocatalytic degradation of some reactive dyes from aqueous solutions under arc-xenon light irradiation. The best result is obtained by wet grading of titanium dioxide with iron oxide, in which case nanometric particles of titanium dioxide are deposed on the surface of micrometric particles of iron oxide. In the future, we aim to optimize the synthesis process by achieving more efficient coupling by finding the right interface. Last but not least, I want to acknowledge the Ministry of Research, Innovation, and Digitalization who support this work. And thank you for your attention.
Thank you, Maria, for your nice presentation at the object and in time. If there are some questions from the room, from online. No, thank you, Maria.
Thank you very
And
much.
good luck for your next purposes. The next presentation is given by Larisa Maria Petrila with harnessing immobilized lacase for sustainable water remediation. It's from online.
Yes, hello.
Yes.
Can you see my presentation? It's full screen, right? Okay. Hello, my name is Larisa Maria Petrila. I'm a PhD student at the School of Advanced Studies of the Romanian Academy. And today I will present some results from the study Harnessing Immobilized Lacase for Sustainable Water Remediation. The presentation today will be comprised of a short introduction, the materials and methods used in this study, some experimental results, perspective, and conclusions. Enzymes are natural protein structures with catalytic activity that operate in mild conditions of temperature and pH. Lacases are multi-copper oxidases, a class of enzymes that is able to convert phenolic and aromatic compounds to much simpler molecules. While very useful for the industrial sector, phenol and phenolic compounds attracted a lot of negative attention in the recent years due to their harmful impact towards the environment and the human health. Based on their substrate specificity, lacases are able to convert such compounds to less toxic molecules. Recent examples in the literature present the degradation of different types of pollutants in the presence of lacase, such as pharmaceutical compounds, phenol aromatic compounds, or dyes. Even though lacases are very potent catalysts, their use in large-scale applications is limited by their difficult recovery and reuse. For this reason, their immobilization has imposed as an efficient method to increase the stability and the reusability of the enzymatic catalysts. There are many examples in the literature presenting different types of support materials for lac immobilization, such as metallic organic frameworks, resin, fibers, or hydrogels. Composite materials can also be used as supports for enzyme immobilization, with a lot of attention being drawn in the recent years by the use of composite materials fabricated with polymers or charged polymers, which represent stable and versatile supports for enzyme immobilization. The materials used in this study are branched polyethylenimine, polyacrylic acid, and polysodium methacrylate for the fabrication of composite materials, glutaraldehyde that was used as a cross-linking agent for the stabilization of the composite materials. For the assay of the enzymatic activity, 2,2-azino-bis-3-ethyl-benzothiazoline 6-sulfonic acid was used as a substrate. Indigo-carmine, a negatively charged sulfonic dye, was selected as a model pollutant. Additionally, ABTS and syringaldehyde were used as mediators for the dye degradation study. The fabrication of the composite materials was achieved by the alternating deposition of polyethylene.
We cannot hear very clear.
Sorry? Can you hear me better now?
Yes, yes.
Okay, sorry. The fabrication of the composite materials was achieved by the layer-by-layer deposition method. For this, polyethylenimine and polyacrylic acid or polysodium methacrylate were deposited on silica microparticles of the isogel type. After the deposition of each polyethylenimine layer, the chains were chemically cross-linked with glutaraldehyde. At the end of the deposition process, the weakly bound polyelectrolyte chains were extracted in strong acid-strong basic media, employing a stabilization flexibilization protocol. The composite materials obtained after stabilization flexibilization were used as support for lacase immobilization by absorption from an acetate buffer solution at pH 4.5. In order to test the potential application of the immobilized lacase in water cleaning, the composite biocatalysts were put in contact with an aqueous solution of indigo carmine at room temperature and under shaking. Small volumes of ABTS or syringaldehyde were introduced in the system in order to facilitate the enzymatic degradation of the dye. The discoloration degradation efficiency was assessed by measuring the decrease in absorbance at 610 nanometers, which corresponds to the dye absorption maxima. The successful fabrication of the composite materials was assessed by using the polyelectrolyte titration method to calculate the amount of organic material that was deposited after each step. We can observe from the graphical representation on the left side of the slide that when using polyacrylic acid as a polyanion, the amount of organic material that was deposited on the support microparticles was much higher due to the high molar mass and the coiled conformation of the polyelectrolyte, which favors the deposition of thicker layers. On the other hand, when using polysodium methacrylate as a polyanion, the amount of organic material deposited was much lower, this polyelectrolyte having a lower molar mass and a stretched conformation. The stability of the composite materials to rinsing and stabilization flexibilization treatment was assessed using thermogravimetric analysis before and after the stabilization flexibilization. We observed that comparing the weight loss for the composite materials before and after stabilization, the difference in the amount of organic material thermally degrading was less than 20%, which confirms that only the weakly bound polyelectrolyte chains were extracted during stabilization flexibilization treatment. The immobilization yield for lacase reached approximately 35% when using as support the composite material fabricated with polyacrylic acid, and about 45% when using the composite material fabricated with polysodium methacrylate. The difference between the two materials is related to the higher hydrophobicity of the composite fabricated with polysodium methacrylate. When immobilizing enzymes by absorption, it is expected that the main forces that lead to enzyme immobilization are electrostatic interactions. In the case of the composite material fabricated with polyacrylic acid, it is expected that this is the main phenomenon that occurs. On the other hand, when using the composite with polysodium methacrylate, it is expected that beside the electrostatic interactions, hydrophobic interactions will also play an important role in enzyme immobilization. The activity of the immobilized enzyme, determined based on the conversion of ABTS and expressed in units per gram of support material, is satisfactory and confirms the amount of enzyme immobilized. Next, we studied the degradation of indigo carmine, firstly in the presence of free lacase, using ABTS or seringaldehyde as mediator. We observed that when using ABTS as a mediator, the degradation efficiency reached 70% after 15 minutes, while when using seringaldehyde, we obtained a 100% discoloration efficiency after 13 minutes, results that confirm that the pair lacase mediator can be used for the degradation of indigo carmine. We also assessed the use of the biocatalyst obtained by the immobilization of lacase in the degradation of indigo carmine, both in the presence of ABTS and seringaldehyde. For the first biocatalyst obtained by the immobilization of lacase on the composite material fabricated with polyacrylic acid, we obtained a 96% discoloration efficiency after 1 hour, while when using the seringaldehyde as mediator, the discoloration efficiency was 100% after 1 hour, results that confirm that the immobilized enzyme is still active and still able to lead to indigo carmine degradation. Moreover, the composite biocatalysts could be successfully reused in several dye-degradation cycles. In the case of the composite material, in the case of the composite biocatalyst used in the presence of ABTS, we observed a decrease in the degradation efficiency after the second reuse cycle, which was most likely the result of the absorption of ABTS cation on the surface of the material, which is hindering the enzyme active site. On the other hand, when using the biocatalyst in the presence of seringaldehyde, we observed a 95% discoloration efficiency after the fourth reuse cycle. The use of the second biocatalyst obtained by the immobilization of lacase on the composite material fabricated with polysodium methacrylate was assessed in similar conditions, observing that in the presence of both ABTS or seringaldehyde, the degradation efficiency reached 100% after 45 minutes. In conclusion, in this study, we obtained a 100% discoloration of indigo carmine by employing biocatalysts obtained by the immobilization of lacase on composite microparticles fabricated by layer deposition of polyelectrolytes. We used two mediators, ABTS and seringaldehyde, and we observed that the pair immobilized lacase seringaldehyde led to a faster discoloration of the dye sample. Moreover, the biocatalysts could be successfully used in several dye discoloration cycles, demonstrating their increased stability. Further studies will be directed towards the optimization of the dye degradation process. The results presented today were obtained during a research stage carried out at the University of Lille in the Bioecoagro laboratory. I would like to acknowledge the Romanian Ministry of Education and the University of Lille for the financial support that made this research stage possible, and to thank you all for your attention.
We thank you, Larissa, for your nice presentation. If there are some questions, one moment, Professor Bravo.
Thank you. Thank you for your nice presentation. I found interesting you have the interesting results, and you have a degradation in which the concentration decreased linearly, like a zero kinetic order. Your reaction doesn't depend on the concentration of your pollutant.
The results presented today are for the same concentration of the dye. I started testing different concentrations, but I didn't have exactly all the results prepared. But I expect it will depend on the dye concentration.
Okay, thank you very much.
Thank you.
Some other questions from online? If no, thank you, Larissa, for your interesting presentation. And I will invite Lyubovy Crețu to present well-dispersed nickel-gold nanoparticles on mixed oxide derivative zinc aluminum, LDH, as efficient catalyst for photodegradation of bisphenol A.
Good morning, audience. First of all, I would like to introduce myself. My name is Lyubovy Crețu, and the team of researchers from the Institute of Physical Chemistry of Bucharest, led by your Professor Florica Papa. With a track record of research and collaborative partnerships, we aim to address well-dispersed nickel and gold nanoparticles on mixed oxide-derived zinc aluminum LDH as efficient catalysts for photodegradation of bisphenol A. First of all, what is bisphenol A? BPA, short for bisphenol A, is a synthetic estrogen, unstable and lipophilic, especially when heated. It is commonly found in various materials such as polycarbonate plastics, epoxy resins, dye coatings on food containers, water bottles, and even in thermal paper used for receipts. In recent years, the concern over environmental contamination with BPA has grown significantly, with its detection in industrial wastewaters, groundwaters, surface water, and even drinking water. Notably, BPA poses a toxicity risk at remarkably low doses, as little as 0.05 milligrams per kilogram of body mass. This poses a serious threat to human health, as BPA has been linked to several disruptions in the hormonal and reproductive systems. The materials we have used are environmentally friendly. Here you can see the general formula for the layered double hydroxides. The materials possess some specific properties. For example, for the LDH, short for layered double hydroxide, we have this high surface area, basic properties, homogeneous mixture of oxides, and as well as the memory effect specific for the LDH. The well-defined nanoparticles present properties such as synthesis-controlled morphology and well-dispersed nanoparticles over support oxides. Assembling nanoparticles with mixed oxide derived from LDH precursors leads to new heterostructures with enhanced photocatalytic performance. The aim of the study consists of the development of efficient catalysts based on zinc-aluminum mixed oxides decorated with well-defined mono and bimetallic gold-nickel nanoparticles, and to synthesize materials for environmental applications, more specifically photocatalytic degradation of bisphenol A under simulated solar irradiation. The process steps of synthesizing nanoparticles on zinc aluminum oxide heterostructure consists of 3 distinct steps. In the first one, the synthesis of mono and bimetallic nanoparticles. The second step, the synthesis of zinc aluminum mixed oxides derived from the co-precipitated LDH. And the first step is the controlled assembling of the two. The scheme of the catalyst synthesis can be seen represented in the figure. The synthesis of mono and bimetallic nanoparticles has been realized using the alkaline polyol method. The precursors used have been the nickel nitrate and chlororic acid dissolved in ethylene glycol, as well as polyvinyl pyrrolidone used as escaping agent. The precursors are heated under 130 degrees in argon atmosphere under stirring for 2 hours. After that, acetone is being added to the colloidal suspension of the nanoparticles to induce the separation. After centrifugations, the nanoparticles are being washed with acetone and dried in 110 degrees. Secondly, the zinc aluminum LDH was prepared using the co-precipitation method at constant pH of 9.5, using the corresponding metal nitrates, as well as the co-precipitation aqueous solution of sodium hydroxide and sodium carbonate. The solution was aged at 75 degrees under stirring for 24 hours. The resulting solid was then calcinated in air atmosphere under 650 degrees, resulting in the zinc aluminum mixed oxides. The first step, the last step consists of the assembling of the nanoparticles with the zinc aluminum derived LDH. And this was obtained by dispersing the colloidal nanoparticles on the zinc aluminum oxide support. We have characterized our catalyst using the following techniques: X-ray powder diffraction, transmission electron microscopy, UV-vis spectroscopy, thermoprogrammed reduction, and hydrogen chemisorption. Here you can see the XRD patterns of the catalysts. In the first spectra, we observe the characteristic reflections of mono and bimetallic nanoparticles. In the second spectra, the well-defined crystalline LDH structure and a small amount of zinc oxide. And after the calcination of the LDH precursors, we observe the specific XRD pattern for the zinc oxide phase. The TEM images of the nanoparticles indicate a morphologic and homogeneous distributions of the mixed oxides, as well as a good distribution of the diameter of the nanoparticles. The assembling of mono and bimetallic nanoparticles with zinc aluminum oxide results in increasing the light absorption, narrowing of the band gap of the obtained heterostructures. For the gold catalyst, we see a specific shoulder at 550 nanometers due to the plasmonic effect of the gold. And for the bimetallic catalyst, we see an overall improvement in optical properties. The temperature programmed reduction measurements were carried out to analyze reductibility of the nickel-supported catalyst, as well as the metal support interaction. Reduction profiles of nickel and nickel-gold catalysts were very similar. In fact, the thermograms can be seen as overlapped peaks with low interaction at low temperature and strong metal support interaction at high temperatures. The hydrogen consumption at low temperature can be assigned to the reduction of the hydroxy species on the surface. The introduction of gold has the effect of increasing the nickel reduction capacity. And here you can see the results from the hydrogen chemisorption presented in the table, which gives us the information that the active component dispersion decreases with the gold being added. The experimental setup can be represented in the picture. Here we have the reactor with a quartz window, a solar simulator, a magnetic stirrer with a steering bar, and a chiller to maintain a constant temperature of 18 degrees. The liquid phase was monitored with HPLC. Here we can see the time evolution of BPA concentration under simulated solar irradiation. We observed that the bimetallic catalyst presents the best catalytic activity, followed by the gold catalysts, nickel, and the zinc aluminum oxide. Conclusions. The catalytic performance of the catalyst was evaluated for the photocatalytic degradation of BPA under simulated solar irradiation. The bimetallic catalyst showed excellent degradation of performance on BPA. The perspectives of the project include the exhaustive physiochemical characterization, XPS and Raman spectroscopy, and further chemical kinetic studies. Finally, I would like to thank you for your attention.
We thank you. Are some questions from room? From online? Is the first presentation? Congratulations. The emotions will be all the time. The problem is to try to be friend with the emotions, even for the experienced people. Congratulations, Ljubovi. And thank you for your nice presentation. We invite Roxana Ioana Matei, okay, to give the next talk about phosphatic nanomaterials with metal oxide heterojunctions photocatalysis for wastewater treatment. Welcome.
Thank you very much. So, hello, dear all. My name is Roxana Ioana Matei. I'm a scientific researcher in team number 7 and also a PhD student at University Polytechnica of Bucharest. And today I'm going to present you a study that I pursued with my colleague Maria Grapin from team number 10 concerning phosphatic nanobiomaterials with metal oxide heterojunctions photocatalysts for wastewater environment treatment. Sorry. So we all know that concerning problem that the scientific community is facing nowadays is the environmental pollution, especially the water pollution, which it's happened because of the industrial and agricultural extensive activities and also due to mankind activities. So our goal was to develop an innovative technology for the elimination of organic pollutants, especially dyes, which are coming from various effluent generating industries, using a phosphatic nanobiomaterial with photocatalytic properties obtained from natural resources, namely muscle shell wastes, through modifying its surface with different metal oxides. We think that our solution can solve two existing problems at the same time, one of them being the transformation of a significant waste into a recoverable product and also the remediation of the pollution. So our specific objectives for this study were, first of all, the synthesis and characterization of the phosphate nanobiomaterials with the aim of using them as photocatalysts with metal oxide heterojunctions. The second one was to optimize the synthesis parameters and the photocatalytic process. Also, we had to demonstrate the efficiency of the obtained nanobiomaterials in the treatment of waters contaminated with organic pollutants, especially dyes. And last but not the least, we had to choose the nanobiomaterial with the highest efficiency in the depollution process. The first objective was fully accomplished because we obtained 3 sets of photocatalysts using as support materials synthetic hydroxyapatite, titanium dioxide, and biosynthesized hydroxyapatite, which we functionalize with the 5 metal oxides of cobalt, chromium, copper, iron, and nickel. I want to mention that the biosynthesized hydroxyapatite was obtained using muscle shells waste, which suffered the grinding processes, and then the powder obtained was calcinated at 1000 Celsius degrees in order to obtain the calcium oxide, which was further used for the synthesis process. The photocatalyst synthesis was done in a microair reactor. After this filtration steps was followed by filtration steps, and then dry to obtain the photocatalyst we used in the studies. In figure 1, we presented the X-ray diffractogram of the biosynthesized hydroxyapatite. We can see that there are present all the specific peaks which correspond to the general structure of hydroxyapatite, and also there is one other peak at 18.05 degrees, which corresponds to a phosphate, disodic phosphate phase. This phenomenon is also explained by the usage of sodium hydroxide to maintain one of the important parameters in the synthesis of hydroxyapatite, namely the highly basic pH of the solution. The thermal analysis of the photocatalyst with hydroxyapatite revealed us a residue of approximately 94% at 700 Celsius degrees. And we can see from the thermogram that the mass losses recorded are being divided in 3 steps. Also, the reflectance spectra helped us to identify which compounds we obtained based on their color, and also to identify the wavelengths of the maximum absorption. The beta analysis, based on the average pore diameter obtained almost 7 nanometers, we can classify the materials obtained as mesoporous according to the International Union of Pure and Applied Chemistry. So the next step was to demonstrate the efficiency of the obtained materials. We chose for this objective 2 pollutants, important pollutants that we find usually in the environment. One of them is a model dicontaminant methylene blue, and the second one is usually used drug ceftriaxone. For this study, we mixed our photocatalysts obtained with a styrene acrylic paint and deposited on side glasses, and the side glasses underwent the photodecomposition process under in a photocatalytic reactor through the visible light. We obtained the photodecomposition of ceftriaxone using the coatings containing hydroxyapatite with iron. In the figure 4, we can see that the degradation of 2-aminothiazole is starting at 274 nanometers, but the slow decrease of the slow decomposition is explained by the presence of the sulfur atoms in its structure that usually poison the photocatalysts based on transition metals. As my colleague presented before, we tested coatings containing titanium dioxide into the photodecomposition of methylene blue, and we obtained 95% decomposition of this dye. But we all know that titanium dioxide is a well-known material for its photocatalytic activities. Also, we tested our biosynthesized hydroxyapatite material for the decomposition of methylene blue, and after 2 hours we obtained approximately 33% decomposition in the case of the simple biosynthesized hydroxyapatite, and almost 26-27 for the hydroxyapatite with iron and hydroxyapatite with the cobalt. So we had to choose which of the materials had the best efficiency in the depollution tests. We concluded that the biosynthesized hydroxyapatite with iron had the best results in this, but we were surprised that only biosynthesized hydroxyapatite, not with other heterojunction, had outstanding results. So in conclusion, the objectives proposed in the study were successfully accomplished. The preparation method of the photocatalyst is simple, involves low temperature and short synthesis time, but also including low cost through the use of shell waste. Photocatalytic degradation of drugs in the presence of metal oxide hydroxyapatite photocatalyst is an effective technique for the treatment of aqueous effluents. Regarding the photodegradation of methylene blue dye from simulated contaminated water samples, biohydroxyapatite and biohydroxyapatite with iron show the best photocatalytic performances. So, in conclusion, the efficiency of the nanobiomaterials proposed for the depollution process was demonstrated involving minimal resources, thus facilitating the development of the bioeconomy. We also helped increasing the scientific institutional research internationally by publishing 2 articles in ICI index journals. And also we submitted one patent application regarding the international and national conferences. We participated at 5, and we had 3 participations in international invention fairs. Thank you very much for your attention.
Congratulations, Roxana. And are some questions from the room, from online? If not, I want to ask you if you intend to apply this type of photocatalyst in real samples and how you are going to reuse it. Is possible to have, yes, most than one application, for example, if you are going to put in a river or something like this in a polluted
It
resource.
is the next step in the study because we just
the
tested,
selection. Okay.
we just tested the materials on the simulated water matrices, and then we want to use them in a real type of wastewater.
Okay, thank you. And
Thank you
good
very
luck.
much.
Okay, so I will invite Andrea Miron to present new adsorbents based on chitosan and inorganic organic composites for efficient remediation of wastewater charged with heavy metals. Andrea.
Hello, everyone. You see my presentation?
Yes, please.
Okay. My name is Miron Andrea. I'm a PhD student and a researcher in Team 1 at ICECHIM. And today I would like to present a part of my study, new absorbent based on chitosan and inorganic organic composite for efficient remediation wastewater charged with heavy metal. The presentation is structured in several chapters: introduction, objective, materials, methods, results, and some conclusion. So pollution is one of the biggest global environment problems. Among of the most common pollutants are heavy metals, dyes, and organic pollutants. Pollutants can be removed by chemical, physical, and biological methods. One of the most widely used technique is absorption using absorbent materials. The advantages of these methods are the high yield of absorption and the use of cheapest and environmental friendly absorbent. For example, chitosan, alginate, zeolites, titanium dioxide, and their composites. The objective of this study are obtaining a new class of absorbent structure with high retention capacity for copper ions and an advanced material characterization and determination of absorption kinetics. The first step of the synthesis of these materials is the homogenization of the chitosan and the composite solution. After the step, the warm solution is added to a syringe and dropped over a natrium hydroxide 5% solution. After 12 hours, the beads are washed with distilled water for the neutral pH and dried by lyophilization. 3 different types of chitosan was used in this study: commercial chitosan, chitosan obtained from commercial chitin, and chitosan obtained from shrimp shell waste enriched with calcium carbonate. Also, the composite was added in different ratio of 10 and 33%. The FTIR spectra show the characteristic peak of both for inorganic organic composite and the chitosan. You can see that in this figure, the presence of the main characteristic peak for the cyan group specific for the acrylonitrile can be observed at 2,242 centimeters at -1. The X-ray diffraction attests the crystalline structure of titanium dioxide and the chitosan. You can see the unattached structure of titanium dioxide present in the composite and also in the beads. And you also can see the peak for specific for the chitosan at 9.8 and 20 degree. Also in the figure, you can see for the sample SHT pen 10%, the peak characteristic for the calcium carbonate at 29 and 40 degree. All the beads present little variation in pore diameter and volume, which means that the filler has a very low influence on the porosity of the composite beads, regardless of the amount used. The largest bed surface area was recorded for the sample SAT pan 10%, which also revealed the largest pore surface area and micropore volume. The obtained data from bed analysis were also confirmed by the morphology by the semi-investigation, which in the case of SH series display the presence of large pore on the surface of the beads. It can also be observed that, the removal efficiency depends on the type of chitosan used and the percentage of the inorganic organic composite present in the structure of the polymeric beads. And the range are from 29.5% to 51.6%. Thus, for the commercial chitosan beads, the removal efficiency is similar for the both filler percent, approximately 30%. For the beads obtained from chitosan from commercial chitin, the percent are approximately 33. And for the beads with chitosan from shrimp shell waste, we have a percent around 50. Using SEM microscopy, elemental mapping, and EDX spectra, we collect for all the series of composite beads after the copper ion absorption. In figure, we can see the EDX spectra, then confirm the presence of the major constituent of chitosan, carbon, and oxygen. In addition, significant amount of copper were found on the surface of polymeric beads with percentage ranging between 3.5 to 60% for the best sample. The final step was the kinetics study was conducted under the same condition at pH 5, 25 Celsius degree, measured as a function of contact time starting from a solution of 100 milligram per liter and a solid liquid ratio of 1.5 milligram per milliliter. Absorption study using chitosan composite beads was performed over a time range from 1.5 hour to 24 hour. The absorption rate was quite fast in the first 7 hours, where attaining equilibrium and forming a plateau. For the better understand the absorption process, the pseudo second order kinetic, LOVIC and interparticle diffusion model was fit into the existing experimental data, and the parameters are summarized in the table. It can be seen that the best interpretation of the experimental data is given by the pseudo second order kinetic model. In conclusion, the spectroscopy confirmed that the titanium dioxide polyacrylonitrile composite was successfully incorporated in the biopolymer matrix. X-ray patterns show an anatase type crystal structure of titanium dioxide and the ordinate crystal structure of chitosan. Beta analysis reveal a higher porosity with a large surface area and pore volume for the sample with SHT pen 10%. The results show that the kinetic model which best fitting that the obtained experimental data was a pseudo second order model, suggesting limited surface area absorption and metal ligand bond formation. The study confirmed that the absorption depends on the type of chitosan and filler percent, and also for the beads with chitosan from shrimp shell waste and 10% of composite are the best. This result was obtained in the youngest grant for youngest researcher, and the dissemination for this project was based on 2 oral presentations, 1 poster presentation at international scientific conference, 1 national patent application, and 1 ISI article. And also I would like to thank you for my colleague Roxana Matei and the member of Team 1 and Team 7 for the support and help in this project. Thank you for your attention.
We thank you, Andrea, for your interesting work. We know that you used us with interesting results. As I understood, you are not in country. I wanted to ask you to switch on the camera because it was better to see you. But anyway,
Sorry, I forgot. I forgot the camera.
Thank you. Thank you, and I really appreciate. If there are some questions from online, it was very interesting. Good luck, and we welcome you back.
Thank you very much. Have a nice day.
Thank you also, Andrea. We will pass to the next. We will ask Ramona Ciobanu if it's possible to have now.
Yes, I restore the connection.
Okay.
If you allow me to present now, I'm able.
Please.
Yes? Okay. It's okay, no?
Yes, yes, it's
okay.
Fine. You can let it like this and just proceed.
Okay, I will share screen. Okay, finally. My name is Ramona Ciobanu, and I'm a PhD student. You see. I will present like this.
Let it like this. Okay, thank you.
It's better. Okay. I'm Ramona Ciobanu, PhD student from Gheorghe Technical University, and I will going to present a batch and column sorption study of heavy metal ions removal. So in this context, the main objective was to create a sorbent because we need to clean the water to clean the water and wastewater for heavy metal ions, and we synthesize and testing sorption capacity of quasi-Servat composite towards heavy metal ions from synthetic solution in batch and fixed bed column experiments. And after that, we compare the sorption capacity between them. So the synthetic composite involve one-pot deposition of inter-polyelectrolyte complex between polyethyleneamine and polyacrylic acid. We can see on the picture how the schematic representation of the synthesis, and we cross-link at a lower degree, at 0.1 cross-linking degree, and in this way we obtain the sorbent that we want to test it. The experimental parameters was they are shown in the table. We tested this sorption capacity through static and dynamic experiment that I said before, and the important influence factor is the initial concentration, and for batch sorption we was a variable, and for fixed bed column we maintain constant. Also, the other important influence factors are the mass composite and the contact time. And after all, the sorption capacity was calculated with the the same formula, but the difference is the initial concentration and the equilibrium concentration from the batch sorption was changed for the fixed bed column with the influent respective effluent concentration. And the concentration was quantified by atomic absorption spectroscopy. The sorption capacity of the sorbent that we synthesized was tested for nickel ions and lead ions through both absorption processes, batch and fixed bed column experiments, because we want to select just one heavy metal after that. And we can see from the graphics, in the case of batch experiments, we see a removal efficiency of lead higher than the nickel ions removal efficiency. Also, this confirmed by fixed bed column experiments. And if we want to analyze the breakthrough curves from fixed bed columns, from the dynamic retention of nickel and the lead solution, we see the breakthrough time for nickel sorption is shorter, and this means the column become exhausted faster than the nickel than the lead ions sorption. So with this retention efficiency for lead and good results from dynamic retention, I continue to present the results just for the lead ions retention. So in batch experiments results, we obtain at the initial at the same we obtain almost 6 milligram per gram sorption capacity, and we fit it after that with Langmuir isotherm, and this is almost a good fitting, but for until now we obtain a good results, but I will repeat it for the other good results, because this I put in my PhD thesis, and until now is quite okay. So in column experiments result, the breakthrough curve was a good fitting to Thomas nonlinear model, and the sorption capacity was almost 22 milligram per milligram. This means almost 4 times higher than the sorption capacity of lead from batch experiments. So this means the dynamic experiments show a good applicability for the real scenarios from wastewater treatment plant. So in conclusion, can I say what the succeed to retention of lead ions in the composite microparticles, also in batch and fixed bed column, but with good results for the column experiment. And like I said before, the fixed bed column adsorption method presented effective alternative for the wastewater, for the real wastewater systems. Thank you very much for the attention and for patience to allow me to present in the end.
We thank you, Ramona, and congratulations. Congratulations for the work. If there are some questions. Yes, Professor Bradu.
Thank you. Thank you for your nice presentation. I would like to ask you, what do you think you have so important difference between the nickel and the lead absorption?
I think because the affinity of our sorbent is higher for the lead. Because of the macromolecular mass is higher than the nickel. I think this is what the reason.
That will be the reason. Okay. Thank you.
Thank you so much. Have a nice day.
Online or some questions? If no, thank you again, Ramona. And we will invite Alexandra Loredana Almășan for On the Environment and Human Health. I understand that the title
Hello.
is... Okay. Can you switch on the camera?
My camera doesn't work, unfortunately. I'm sorry.
Okay. Okay.
Hello, everyone. My name is Alexandra Loredana Almășan. I'm a master student at the University of Bucharest, medical bioinformatics program. I will present you a short study about computational approaches regarding the effects of cyclic aromatic hydrocarbons on the environment and human health. I will start with a brief introduction. Rapid industrialization and urbanization have resulted in pollution from anthropogenic activity, which releases various compounds into the environment, including PAH. They are persistent pollutants and they have a wide range of biological toxicity. So remediation of these compounds from the environment has been a global concern. Also found equally in aquatic and terrestrial ecosystem, as well as atmosphere. Also, these compounds have helpful effects on human health. The purpose of this study, this work evaluate in silico the physicochemical properties, the pharmacokinetic and pharmacodynamic profile, the molecular target, and the mathematical correlation of the various properties. A set of 9 compounds, including crescine, benzoapyrene, diabenzo anthracene, fluorantine, naphthalene, anthracene, phenanthrene, and pyrene, and also benzofluorantine was used in this study. The PubChem database was used to extract the simplified molecular input line entries, miles, file, and physicochemical properties of selected compounds. Also, Swiss ATME was used for to extract the physicochemical properties, to study the absorption, distribution, metabolism, expression, and toxicity. ADME profile in silico, we used the online tool ADME Lab, ADME CAR 2.0, and also databases PKCSM and Protox. For calculation bioactivity of compounds, we use computational software Inspiration, and to predict potential targets for polycyclic aromatic hydrocarbons, we used SuperPred database. in this image, in this table, we have such physical-chemical properties of selected compounds. We can observe that our small molecules, molecular weight is small, partition coefficient is positive, so the compounds are hydrophobic, with moderate or low solubility in water, with a big number of heavy atoms and good molar refractivity. All compounds completely with Lipinski and Weber-Dragnein's rules. They have potential for drugs, for discover new drugs. Also, they are good gastrointestinal absorption and good skin permeability. The compounds easily cross the blood-brain barrier, and have a high permeability to the central nervous system, which demonstrate that they affect the central nervous system. Substances are rapidly metabolized in the body. The fact that they represent both substrate and inhibitors demonstrate that the concentration in which they are found in the body is important. At low concentration, they are substrate for cytochromes, and at high concentration, they can inhibit cytochromes. Also, most compounds have a moderate or low total clearance, which show that they can be difficult to eliminate from the body. With regard to ecotoxicity, the compounds is toxic for phytoplankton, crustacea, and Trichoderma piriformis, but they doesn't toxic for are not toxic for honeybee, and the compounds have low biodegradation. With regard to human health, compounds cause adverse system on the skin, eyes, mutagenicity, carcinogenicity, and nephrotoxicity, and immunogenicity. It also affects the various repeller and signaling pathways. Such can observe in this table. Also, they are not cytotoxic or immunotoxic, according to Protox 2. In this slide, we can observe graphic representation of bioactivity of compounds. Lowest bioactivity is from naphthalene. Here we can observe representation of variation of different properties. Most hydrophobic compounds is dibenzo AH anthracene. Also, this compound is are heavy, big heavy atoms, and also molar refractivity, big molar refractivity and solubility. The best univariate correlation of compounds was obtained in correlation between coefficient partition and blood-brain barrier permeability. Here we can observe predicted targets in SuperPred. The most likely predicted target for the analyzed compounds was DNA aspartic or apyrimidinic acid liasa, and we visualize this protein in protein data bank, structural file code 6BOW. Conclusion: computational methods offer perspective for the design of new compounds that have fewer adverse effects, as well as the remediation of the effects of existing toxic compounds in a rapid and economic way, compared with in vivo, or in vitro analysis. Thank you so much for your attention.
We thank you for your presentation. Are some questions from, yes, Professor Brad?
Hello, thank you. I'm curious if you take already into account, or if you want to take for further research, the exposure of the organism, and what will be the daily intake of these pollutants?
Yeah, it's an interesting subject for future research.
Okay. So, thank you.
Thank you.
Thank you. From online? If no, thank you, Alexandra, and we will ask George Mihail Teodorescu to present influence of treatment ash waste on the properties of glass fiber reinforced polyamide 6 and polyamide 6, polyamide 10 hybrid composites. With this work, we are passing through the waste recovery, I suppose. So please, George.
Just one moment. All right. Hello, everyone. I will first start with a bit of an apology. I'm coming down with a pretty nasty cold, so sorry in advance if I cough or have any interruptions during the presentations. Polyamide 6 reinforced with glass fiber is a polymer composite that offers exceptional strength, durability, and stiffness. It is widely used in various industries, including the automotive, aerospace, construction for its excellent properties. Bio-based polyamide 1010 is an emerging polymer with great mechanical properties and is a good replacement for petroleum-based polymers, but it does have the downside of being very expensive. Fly ash is also seeing developments in its applications. It is a waste material that can be used in composites as it presents the structure and behavior of aluminosilicate materials. The objective of this study is to investigate the influence of ash waste treated with 3 different agents on the properties of glass fiber polyamide 6 and polyamide 6 polyamide 1010 hybrid composites. We used polyamide 6 reinforced with 30% glass fiber and bio-based polyamide 1010 as the polymer matrix. We conducted 2 series of experiments. One where we mix the glass fiber reinforced polyamide 6 directly with treated ash. And this series is marked as the PA6 series. And the other one where we mixed the glass fiber reinforced polyamide 6 with polyamide 1010 and the treated fly ash. And this was marked as the PA6 PA10 series. Fly ash was treated with 2 dispersion agents and a coupling agent, a polyester diol, a metal salt of a fatty acid, and a silane. By melt compounding and in the obtained samples, 5% of the glass fiber weight was replaced with treated ash, so that all composites have 30% concentration of glass fiber and ash. And the composites were prepared in dynamic conditions through extrusion and injection molding for dynamic, mechanical, thermal, and tribological characterization of properties. So firstly, looking at the dynamic mechanical analysis, the results show that for the PA6 series, a decrease compared to PA6F, which is let's say a neat polyamide 6 with 30% glass fiber, no added ash or bio-based polyamide 1010. We saw a decrease in storage modulus and stiffness by 5 to 10% for the composites treated with the polyester and the metal salt, and 18 to 90% for the composite treated with the silane. An increase in the loss modulus and loss factor is observed for the metal salt treatment and the polyester treatment, indicating an improvement in viscous properties due to strong polymer ash matrix adhesion. And for the polyamide 6, polyamide 10 series, both the storage modulus and the stiffness of the ash-treated composites decrease compared to polyamide 6F by 15 to 17% for the storage modulus and somewhere between 8 to 16% for stiffness. So these results indicate an increase in flexibility for the materials, which may be caused by the plasticizing effect of the polyester diol and the metal salt of the fatty acid. The thermal analysis revealed a similar thermal stability for the 2 series of samples compared to polyamide 6F until 230 degrees, which is the temperature at which the composites were processed. The table shows that up to 100 degree, up to 100 degrees, the loss of mass is insignificant as a result of the drying process of the materials before processing. And this aspect is particularly important in the case of polyamides, such as polyamide 6, because this polymer matrix has very strong hydrophilic behavior. And after 400 degrees, the samples start to decompose, all having the same thermal behavior, a single decomposition step, as you can all see. Treated fly ash composites begin to decompose at a temperature of 6 to 15 degrees lower than polyamide 6F. and decompose at a maximum rate at a temperature of 7 to 16 degrees lower than the same polyamide 6F. The largest decrease is observed in the case of ash modified with a metal salt agent, while the silane treatment showed the best thermal stability compared to the other treatments. And also the residue at 750 degrees correlates with the amount of inorganic material present in the composites, which is 30% for both series. Now, the results for DSC analysis indicate differences between the composites where the melting and the crystallization temperatures decrease by a maximum of 5 degrees for the composites containing treated ash compared to the control composites, the control composite PA6F in both series. And these decreases may indicate a plasticizing effect of the agents used to treat the fly ash surface, as the crystallinity values correlate well with the modulus and stiffness results from DMA analysis, indicating more flexibility for the ash-treated composites. From a nanomechanical point of view, both series showed a slight increase in reduced modulus by 2 to 5% compared to PA6F. In terms of hardness, a decreasing trend can be observed in composites with treated ash compared to PA6F. The exception is the sample with ash treated with silane from the PA6-PA10 series, where the hardness increases by 41%. This sample also shows the highest value for the reduced modulus. So this behavior confirms the increase in flexibility because a higher modulus would indicate that the samples have a higher capacity for elastic recovery once the force of the indenter is stopped. So based on present and previous results, the silane agent acts more as a coupling agent between the fly ash and the polymer matrix. Now, from the scanning pro microscopy imaging, these images are resulted from before and after nanoscratching occurs on the surface. So you can see that both the orientation of the material in the mold during injection molding and the scratch pattern on each sample can be easily observed. The difference in roughness before and after the scratch, as well as the coefficient of friction, increase with the addition of treated fly ash compared to PA6F. So in conclusion, by introducing 5% treated ash in glass fiber reinforced composites based on polyamide 6 or PA6-PA10 mixture, composites were obtained with similar thermal stability to PA6 with 30% glass fiber at the processing temperature. They have improved flexibility due to the plasticizing effect of the surface treatment agents, and improved surface properties based on rigidity and hardness values, especially when using the silane coupling agent. The high flexibility without decreasing the stiffness by more than 20% in the composites with 5% ash and 25% glass fiber recommends these composites as an alternative to the composite with 30% glass fiber as usable materials for applications in industries such as the automotive industry. And with that, I would like to thank you all for your attention.
We thank you for your very nice presentation and congratulations for your work. If are some questions for Georgia from online, thank you and stay healthy.
Thank you.
We will invite now Anna Maria Baroi for giving the presentation, valorization of viticultural byproducts for the development of nanomaterials with bioactive properties.
Hi everyone, I'm Anna Maria Baroi, scientific researcher and member of team number 7 Emerging Nanotechnologies at ICECHIM Bucharest. Today I will talk about the valorization of the viticultural byproducts for the development of nanomaterials with bioactive properties. Residual biomass accumulated as a result from the grape processing technologies, as well as from grapevine crops conservation techniques, are currently underutilized, having a low economical value. So the main goal of the work was to reuse the viticultural waste through the development of new nanomaterials with bioactive properties in order to integrate them into the circular bioeconomy. So the proposed objectives of the work was to obtain natural extracts. The second objective was represented by the synthesis and characterization of metallic nanoparticles. And the third one includes the evaluation of the efficiency of the obtained nanoparticles by studying their bioactive properties. As mentioned before, the first step was to obtain natural extracts from waste with increased yields of phenolic compounds, and the raw materials selected were represented by two types of grape pomace and other two types of grapevine shoots. After the raw material have been shredded, two solid liquid extraction methods have been applied, a classical one using an oven and a microwave assisted extraction with a microwave digestion system using two solid liquids ratios of 1:10 and 2:10 weight per volume between the raw materials and the solvent. After the extracts were obtained, they have been characterized by identifying their total phenolic content using the spectrophotometry method with Folin-Ciocârteu. From the results, it can be observed that the total phenolic content of the samples is varying is depending on the raw materials used, the ratio applied, and also from the extraction method. The best results were obtained in case of the extracts obtained in 2:10 ratio. And it can be observed that these results were obtained in case of the modern extraction method. So these results were currently selected for the further experiments. The photosynthesis methods of nanomaterials were evaluated, and to facilitate this process, the 6 extracts were combined with a metal-containing solution in 1:1 or 1:2 ratios, with or without stirring. And in order to obtain important information about their formation, nature, and structure, they have been characterized by different non-destructive techniques. So the first step carried out was in order to confirm and to follow the formation over time of the nanoparticles, consists in the evaluation of the UV-Vis absorption spectra of the samples, which were measured at various time intervals in the wavelength range of 300 to 700 nanometers. The UV-Vis spectra of the samples show the appearance of the specific silver nanoparticles absorption spectra peaks in all cases of synthesis protocols. In case of the nanoparticles photosynthesized in a 1:2 ratio, exhibited a better defined absorption maximum for silver, and the peaks have shown tend to shift towards shorter wavelengths, indicating hypsochromic effect. So the UV-Vis spectroscopy confirmed the formation of the nanoparticles in all the synthesis protocols, and in a relatively short time of 96 hours. From the XRD techniques, the XRD technique was used to confirm the formation of the nanoparticles, and the samples display the diffraction peaks which correspond to 3 diffraction planes, which are indicated. And the phase is can be identified as silver in a cubic crystalline system. Also, the total phenolic content of the samples was a very important aspect, because in the case of the ones synthesized with the microwave extract, they have been exhibited as a smaller crystallite size. From the transmission electron microscopy was used to visualize the size and shape of the nanoparticles. The size distribution was determined by measuring direct measurement of over 100 nanoparticles. And from the TEM images, it can be observed their spherical or semi-spherical shapes. And from the size distribution curve of the nanoparticles, they have exhibited on average diameters between 20 and 39 nanometers. The last goal was to evaluate the bioactive properties of the nanostructures by studying their antioxidant properties, electrochemical and antimicrobial properties. The antioxidant activity was determined by the DPPH assay, and the best results were obtained in case of the ones which were photosynthesized with microwave extract. And in fact, this it would be expected because of the total phenolic content obtained for this type of extract. The electrochemical, sorry for my, the electrochemical profiles of the samples were similar, with an intensity oxidation current present at the electrochemical potential. Sorry. For the electrochemical potential of 0.1 volts, being higher in case of the ones synthesized in 1:2 ratio. Also, the reduction of silver ion takes place at the potential of minus 0.3 volts. The antimicrobial properties of the samples were evaluated by qualitative and quantitative tests on gram-positive bacteria. From the qualitative tests, best results were obtained in case of the ones of the nanoparticles which were synthesized with classical extracts. And from the quantitative tests, best results were obtained for the ones photosynthesized in 1:1 ratio, but with microwave-assisted extraction extract, inhibiting about 60% of the bacterial growth, in comparison with the one which inhibited 33%, which correspond to the nanoparticles photosynthesized in 1:1 ratio with classical extract. The study, covering a period of 12 months, led to the full achievement of the proposed outcomes, and the obtained results have been disseminated through the publication of 1 patent application, 3 articles in EC-rated journals, from which 2 are still under evaluation, of 1 book chapter, and by participating to 4 international scientific conferences. In conclusion, the fulfillment of the study led to the development of advanced models focused on the most effective, fast and economic methods for utilizing viticultural and winery waste by photosynthesizing metallic nanomaterials with bioactive properties with a various range of application. Thank you very much for your attention. And also I would like to give special thanks to all my team colleagues and also to Christina Firinca for the antimicrobial test performed. Also to Ioana Hosu for the electrochemical tests. And finally to Bogdan Trică for the transmission electron microscopy results. Thank you.
Thank you, Anda, and I really appreciate your effort to finish your presentation. It was very, very interesting. Are some questions in room from online? I will have one question. How are you going to use further your results?
I want to integrate them. I already integrate them in some cosmetic formulations, and I would like to do the same thing, but with other applications. The first cosmetic formulation was developed for the UV block, like SPF.
Okay, because I was thinking that maybe you are putting attention also on the natural extracts with the antioxidant activity, but also for the nanoparticles, the silver nanoparticles, and not only for the antimicrobial activities. That's why I was asking you. It's a good point, and not only for the cosmetics, but also for food and
for food or
health.
textiles.
Yes. Oh. Yeah. Okay, good luck and thank you. We will invite now Luisa Mirt to give the presentation, lignocellulosic waste derived biochar, synthesis and activation for agriculture applications. Welcome.
So, hello, I am Luisa Mirt, member of team number 2 here in ICECHIM. And today I will show you some results that me and my team have on lignocellulosic waste derived biochar, how we synthesize and how we try to activate this biochar. So the aim of this work was to evaluate the biochar derived from lignocellulosic waste resulting from the slow pyrolysis of wheat straws before and after subjecting the biochar samples to activation treatment. What is biochar? Biochar is a natural fertilizer and support material for controlled release of nutritive elements, having a positive effect on the environment, such as reduced eutrophication risk, atmospheric carbon capture, and amendment for degraded soil, while also providing an excellent absorption capacity for environment contaminants. So our premise was to use this lignocellulosic waste resulting from crops serve as feed to produce biochar, which can be further used as soil amendment. For the first experiment, the slow pyrolysis, our experiments were carried out using a tubular slow pyrolysis reactor, where we use nitrogen as inert gas and wheat straws as feedstock. The biochar samples were heated at 2 temperature. Here we used 600 Celsius degrees and 750 Celsius degrees. And maintain at this temperature for 2 hours to allow the reaction to take place. After these 2 hours, the liquid and the gaseous phase was allowed to cool and separate this in order to analyze both of these phases. And the biochar was also allowed to cool in the reactor, and after that was analyzed and activated. The activation was carried out in 1 liter autoclave with mechanical steering and maintaining temperature and pressure, a constant temperature at pressure at 200 Celsius degrees and 2.2 megapascal. We use a solvent aqueous solution of 10% potassium hydroxide for the activation. and at a ratio to biochar to liquid at 1 to 20. The reaction took place 1 hour at 200 Celsius degrees with a ramp of 200 Celsius degree per minute. The biochar before and after the activations were analyzed using SEM coupled with EDX. And while the SEM analysis didn't show us some structural properties on how the activation method affected the physical structure of biochar, the EDX showed us an increase in potassium, almost 4 times higher in the activated samples over the control samples. The same thing happened in the samples obtained at 750 Celsius degrees. And with porosimetry analysis using a gas sorption analyzer, we saw how our activation method had some positive effect on the structural of biochar. More specifically, we saw an increase in specific surface and total pore volume in both our samples. So regardless of the temperature we used at slow pyrolysis, we obtained higher specific surface and total pore volume in both our samples. And if we talk about temperature, we saw some increase in average pore diameter when we use a higher temperature in the pyrolysis. So we concluded that our activation procedure was beneficial if we talk about our physical chemical characteristics of biochar. We saw that both specific surface and total pore volume increasing, while pore diameter decreases by less than 10%. But this shows us that the activation method that we used did not collapse our pores. So in the end, we obtained some activated samples loaded with potassium, which is beneficial for agriculture application of biochar. So this procedure allow us for a waste stream to be upgraded in the form of soil amendment and fertilizer. But as I said, it's some preliminary results. So we will go with our experiments to see what we will obtain. And thank you.
Thank you for your nice presentation. And if there are some questions from online. If no, thank you again and good luck. Now we invite you to a short break for 20 minutes.
Good afternoon, everyone, and welcome to the second part of the plenary session. We'll begin with Anna NeXT-Chem with the work entitled Quality Evaluation of Solid Biofuel from Coal-Fired Agricultural Waste. Anna, are you online?
Yes, hi everyone. Just a moment.
Please.
Can you see my...
Yes.
Okay.
If you can pass on full screen.
Just a moment. Hi everyone, my name is Anna NeXT-Chem. I'm a scientific researcher at the Institute of Physical Chemistry, Ilie Murgulescu of Romanian Academy, Chemical Thermodynamics Laboratory. The title of my presentation is Quality Evaluation of Solid Biofuel from Coal-Fired Agricultural Wastes. With the aim to produce heat, fossil fuels can be replaced by local biomass resources in order to reduce the pollution of atmosphere caused by greenhouse gas emissions. In the energy sector, all over the world, there is a need for a fundamental transformation due to the changing climate circumstances. The European Union's energy strategy by 2027 establishes that up to 50% of renewable energy produced by European Union member states will derive from biomass. In figure 2, we can observe that in Romania, the technical energy production potential, first place is occupied by biomass and biogas, followed by solar, wind, hydro, and geothermal energy. Agricultural residues are carbon-based materials generated as byproducts during the harvesting and processes of agricultural crops. Agricultural wastes can be classified due to their provenance in 4 main classes: wastes from soil plantations, waste from food industry, breeding and slaughter wastes. Large quantities of crop residues are produced annually worldwide and are vastly underutilized. An ideal biomass fuel the ideal biomass fuel characteristics are high calorific value, low moisture content, sustainably sourced, low ash content, and a low density. Co-firing biomass with coal is a subject of great interest worldwide. Co-combustion is the burning of more than one fuel to produce power. Co-firing biomass with coal.
Sorry, Anna, can you move the slides while you're talking, please?
Now you can see.
No, only the first slide is shown.
Sorry, a new share.
Can you press F5?
Yes.
Or with the mouse to see slides? Go to slide 2 or 3 with the mouse or with the arrows.
Yeah, I try with the arrows.
No, no movement. We are only seeing your first slide.
New share. If I take new share screen.
Yes, now.
Yes. Yeah. This you can see this.
Okay, now.
I'm sorry. It's okay now. This
yes,
way.
It's okay. No, you pass.
I was here.
Okay.
But the co-firing process, you can see now.
Yes.
Co-firing coal with biomass has been considered as an opportunity to decrease the dependence on coal and its associated impacts. In the present study, we co-fire coal and some cereal grease powders like sorghum, rape, soya, and sunflower grease. And we use 2 types of another biomass like grape pomace and corn cob, using 3 types of additives like sawdust, starch, and waste rapeseed oil. Burning biomass with fossil fuel and different additives and binding agents has a positive impact both on the climate and the economics of power generation. Biomass coal co-firing means reducing carbon dioxide and sulfur oxides emissions, and it may also reduce nitrogen oxygen emissions and represents a near-term, low-risk, low-cost and sustainable energy development. The suitability of a particular biomass as a potential feedstock for biofuel productions depends on various characteristics such as higher heating values, volatiles, fixed carbon, energy density, fuel value index, nitrogen and sulfur content, and also depends on their bulk densities, moisture and ash content. The experimental measurements were performed using a combustion calorimeter in order to obtain the calorific values of the agricultural wastes. The sample were used in the form of pellets. We obtained the pellets using a manual pellet press. The form of pellets is the most generally used for solid biofuel, as they combine a high energy density and quality standards that ensure easy handling and transportation. We present our results. We plotted the higher heating values obtained versus moisture and ash content. The ash quantity was calculated from the difference of the bomb crucibles masses before and after combustion. The moisture content was expressed as the water proportion contained in the ground biomass. It is known that moisture content is the most important factor that influences the calorific value of biomass. From the represented plots, it can be seen that the lower heating values of the studied biomass samples are caused by high moisture and ash contents. Addition of 10% of waste rapeseed oil in the samples of corn cob seems to be the most suitable raw material for pellet production. The highest value of combustion heat, amounting 20 megajoule per kilogram, was observed for pellets made from co-fired sunflower grease. Addition of waste rapeseed oil significantly increases the calorific powers in gray pomace and corn cob pellets. The calorific values of corn cob control pellets were also increased when adding 10% waste rapeseed oil from 70 megajoule to 19 megajoule per kilogram. In figure 12, we have plotted the fixed carbon content, volatile matter, sulfur, and nitrogen content for the investigated samples. And also in figure 13, the fixed sulfur and nitrogen content. Knowing the nitrogen content of biomass is important to assess nitrogen oxides that are air pollutants. So from figure 12, it can be ascertained that the presence of additives of 10% results in decreasing the nitrogen content of the investigated samples. The sulfur levels for control samples are lower compared to coal, this making them emit less sulfur oxides than fossil fuel. Blending coal with biomass reduce the fossil-based carbon oxide emissions. And from this study, the pellets from sorghum and soybean grease biomass seems to be very suitable for a clean and efficient combustion. In table 1, we have calculated the bulk density, fuel value index, energy density, and combustion efficiency. The fuel value index is introduced to determine the suitability for the energy production. In accordance to the literature, higher fuel value indexes are obtained for good quality fuels. Energy density or caloric density is the amount of energy stored in a given volume of the material. And combustion efficiency is a measure of how well the fuel is being burned. The quality of the fuel increases when increases energy density. The samples with the highest energy density and fuel value index were 10% waste rapeseed oil, grape pomace, and 10% waste rapeseed oil, corn cob, demonstrating that the waste rapeseed oil is the best additive for enhancing the quality of the pellets. From figure 14, it can be seen that energy density and fuel value index are higher in the case of co-fire samples than non-co-fire one, thus highlighting the importance of the co-firing procedure. In conclusions, the pellet made from agricultural waste are some of the most popular biofuels. The biomass pellets from this study have a calorific value range between 16 to 22 megajoule per kilogram. Addition of waste rapeseed oil applied at a rate of 10% relative to the weight of the pellets increase their calorific value. The comparative analysis of biomass calorific properties are performed to emphasize that agricultural residues can successfully be used for renewable energy production, replacing the traditional and pollutant coal. Our studied samples, especially co-fire ones, offer an alternative material for energy use, which meets the requirements of minimizing carbon oxides, nitrogen, and sulfur oxides emissions. The obtained results will complete the existing databases concerning the properties of solid biofuel from biomass containing the mentioned co-firings. Thank you for your attention.
Thank you to Anna. Congratulations on your work. If there are any questions from online? No, so thank you again.
Thank you.
Pass to Toma Raluca Marieta with development of moisturizing creme formulation based on royal jelly, hyaluronic acid, and damask rose water. Are you online?
Yes. Do you see my presentation?
Yes, it's okay.
Okay, so I will start. Hello, everyone. My name is Raluca Marieta Toma. I'm almost a graduate PhD student, and today I will present you just a few data from our latest scientific work intitulated Development of Moisturizing Cream Formulation based on royal jelly, hyaluronic acid, and damask rose water. Our principal aim for this study was to investigate the behavior of royal jelly in a cosmetic formulation. For that, we established, of course, a work plan, which involved the synthesis and the characterization of our cosmetic product by various laboratory techniques in order to obtain some incredible results, I guess. Just a short introduction about our major components: hyaluronic acid, royal jelly, and damask rose water. Hyaluronic acid is a natural biopolymer with great and unique properties for the skin, especially for wrinkle reducing and water molecules binding capacity. Also, royal jelly has biological activity, is extracted from honeybees, and is enriched with many peptides, vitamins, various proteins, and fatty acids. And also, damask rose water is a rose hydrosol with antimicrobial properties. Our moisturizing cream formulation ingredients are presented in this table. We have 3 phases. The first phase contains the oil components: almond oil, organic shea butter, and an emulsifier. For the phase B, we have the water components, the rose hydrosol and the pure water, and for the C phase, humectants and other ingredients, hyaluronic acid, royal jelly, vitamin E, perfume, or maybe essential oil, and of course, a preservative. We investigate the physicochemical characterization of our final product, such as pH, physical and visual appearance, color, texture, smell, consistency, homogeneity in afterfeel, touch, and stability. Our product has a fine texture, white color, a fluorescent, nourishing properties, great spreadability, a pH between 6 and 7, stable at the room temperature, stable in time, and I've tasted on my own skin, so it doesn't have any skin irritation possibilities. Because we created formulation, this type of oil in water emulsion has to be validated through different type of tests. So we did a dye and a dilution test. In the left part are a couple of microscope images at 10 and 40x magnification for cream sample with 2 drops of methylene blue. We can see the colorless globules on a violet background, and in the right side we observe 2 tubes with the same amount of cream. In the first one we put an amount of water, in the second one an amount of oil, and we visually observed the oil in water emulsion formation. For different type of oils, butters, and lipids, we have to analyze experimentally the acid and saponification values. We obtain 6.75 milligrams of potassium hydroxide per moisturizing cream, and free fatty acid content of 3.375%. We don't have any data from the scientific reports to compare with, so we put here just the active ingredient, the values from the active ingredient, from the almond oil, from the shea butter, and from the olive emulsifier. Next, the saponification value, 212.265 milligrams of potassium hydroxide per gram of sample. Also, we put down the values for shea butter, the almond oil, and for our emulsifier. Further, we investigate the rheological behavior, but here I would choose to present you the viscosity and function of shear rate, which decreases with the shear rate at the room temperature. Is normal for cream. We have also FTIR measurements for the pure compounds, for the hyaluronic acid and royal jelly, and for our dried cream sample. We observed so many shifts in the spectrum of our cream because there are many interacts between polyphenols, active groups from polyphenols, and fatty acids with hydroxyl groups from our biopolymer. So we have to do a mass spectrometry analysis further. Some conclusions, we obtain a formula which was synthesized and characterized, was stable, fluid, with a white color and the fluorescent. We investigate the rheological properties and also the FTIR spectroscopy, but our study is in progress. Thank you for your kind attention.
Thank you too for this nice presentation. If there are any questions? No? If not, I want to ask you if the raw materials are only commercial?
Yes, we obtained a royal jelly product from France, and also the hyaluronic acid with high molecular weight from Sigma Aldrich. So
maybe for the next test, you will try to extract some flower compounds, local flowers, maybe.
that will be interesting. Thank
Yes,
you.
so good luck with your formulations. Maybe we'll see them in the future on the market.
Thank you very much.
We'll pass to the next presentation, exploring the therapeutical potential of aloe vera and honey formulations for skin wound healing by Iosegeanu Andreea.
Good afternoon. I hope you can see my presentation.
Yes, it's okay.
Great. My name is Iosegeanu Andreea. I am a PhD student at the Faculty of Biology, University of Bucharest, and also a research scientist at the National Institute of Research and Development for Biological Sciences. It is my pleasure to present to you today on the topic of exploring the therapeutic potential of aloe vera and honey formulation for skin wound healing. Thank you for joining me today. One moment. Aloe vera and honey have been used in traditional medicine for thousands of years, including in ancient Egyptian, Chinese, and Roman cultures. Nowadays, both continue to hold a significant place in modern medicine, exhibiting numerous properties, such as antibacterial, antioxidant, anti-inflammatory, and anti-tumor properties. This study aimed to investigate the effect of aloe vera and honey mixtures on cell proliferation, collagen synthesis, cell protection against oxidative stress, and cell migration in order to explore the potential use in novel formulations for skin wound healing promotion. Now I will present to you the work scheme. The aloe vera extract was obtained by ethanolic extraction of freeze-dried aloe vera gel, which was then evaporated to dryness. On the other hand, the honey was dissolved in distilled water in order to reach 20% solution. For both extracts, we analyzed the total phenolic content using Folin-Ciocâlteu method. For cell culture experiments, aloe vera residue and honey solution were resuspended in growth medium and combined in 1:2, 1:1, and 2:1 mixing ratios. In terms of biological activities, we assessed pro-proliferative activity by neutral red assay, collagen synthesis by circle test, antioxidant effect by exposing treated cells to hydrogen peroxide followed by neutral red assay, and cell migration by scratch assay. All the cell culture tests were performed on human dermal fibroblast cells. Results and discussions. The aloe vera extract presented a higher total phenolic content compared to honey solution. Regarding cell culture test, we conducted a preliminary study testing 16 combinations of aloe vera and honey concentrations to identify favorable combinations. From all of these, we selected 3 combinations of concentrations for further analysis. From all those 3 combinations of concentrations presented up to 7% higher proliferation rate compared to untreated cells. Regarding cellular morphology, the treated cells presented a similar morphology to untreated cells, to control group. Circle test showed that collagen secretion increased in cell treated with each formulation. Aloe vera honey 1:2 ratio, meaning 0.25 milligrams per milliliter aloe vera extract and 0.5 milligrams per milliliter honey, had the highest stimulating effect. Looking at the antioxidant activity, all aloe vera and honey formulations showed protective effect against hydrogen peroxide-induced oxidative stress. The formulation with the highest concentration of aloe vera and honey is 1:1, meaning 0.5 milligrams per milliliter aloe vera extract and 0.5 milligrams per milliliter honey. This one exhibited the greatest antioxidant activity. Looking at the scratch assay, all the 3 combinations of concentrations exerted significant higher repel rate of scratch. with wound closure rate up to 15% higher compared to untreated control. Aloe vera honey 1 to 2 formulation, again, 0.25 milligrams per milliliter aloe vera and 0.5 milligrams per milliliter honey was the optimal combination of concentrations. In conclusion, the aloe vera and honey extract formulations demonstrated complementarity action to enhance cell proliferation and migration, collagen production on one hand, and the antioxidant activity on the other hand in human dermal fibroblast culture. The highest stimulatory activity in main stages of wound healing process was found in aloe vera honey 1 to 2 formulation. And based on the presented results, it can be concluded that aloe vera extract and honey showed promise for further exploration and development of novel dressing for skin tissue regeneration. Thank you for your attention.
Thank you to Andrea. Any questions from the room and from online? No? Thank you again.
Thank you.
We'll pass to the next presentation, Constantin Andrea, with microphilic fermentation of bee pollen, improving the functional profile of a traditional fermented beverage.
Hello everyone, my name is Andrea Constantin and today I will present you the microaerophilic fermentation of pollen, improving the functional profile of a traditional fermented beverage. To highlight the functional profile of enriched with bee pollen drink, we assess the total polyphenolic content, total flavonoid content, total hydrocycinamic acids and antioxidant activity using colorimetric method. But it's important is to assess the carbohydrate content and soluble silicon. More of that, we go to biological analysis, such as antibacterial activity, prebiotic activity, cytocompatibility, and in vitro antioxidant activity. Borscht is a traditional fermented beverage from the spontaneous fermentation of wet bran and corn flour. It is commonly used in culinary practice to enrich the flavor and enhance the taste profile. Our study focused is the innovation to fermentation process and mesh by incorporating polyfloral pollen. This innovative approach aimed to explore and harness the health benefits of pollen in the traditional beverage. Because we need to increase the reproducibility. For that, we need to assay the palynological analysis and then take the bee pollen, put in the contact with wet start and borscht yeast. The optimization process will, during the optimization process, we will obtain a drink rich in fructolactobacillus, lactobacillus, acetic acid bacteria, and yeast. More of that, we had the prebiotic, probiotic, and postbiotic compounds with a high cytocompatibility and in vitro antioxidant activity. And we can name our product is a multibiotic product. By including bee pollen in the fermentation process, we will have the threefold increasement of the total phenolic content and twofold increasement of the total flavonoid and hydrocycinamic acids. More of that, the antioxidant activity will increase with the increasement of the bee pollen concentration. Because bee pollen is rich in carbohydrates content, we had the same trend, increasement by increasing the concentration of bee pollen. The same observation we had to the silicon content. To analyze the antimicrobial activity, we choose for different pathogenic strains, such as Pseudomonas aeruginosa, Pseudomonas aeruginosa, Enterococcus fecalis, Staphylococcus aureus, and Bacillus cereus. The inhibition zone show us Staphylococcus aureus is susceptible to inhibit the Staphylococcus aureus stain. And the minimal inhibitory concentration for the plain samples to inhibit the growth of the pathogenic stain Lactobacillus cereus is 63 milligram per milliliter of sample. But when we added the bee pollen, the concentration will decrease and we will have only 60 milligram per milliliter for increase the pathogenic stain. The semi-maximal concentration show the same trend. If we will use only the plain sample, we had a concentration higher, like 46 milligram per milliliter, and for enriched the drink with bee pollen, only 9 milligram per milliliter. 24 hours after incubation, the prebiotic stain with a multibiotic product, a significant increase of Lactobacillus reuteri was observed following treatment with the samples, plain borscht and borscht enriched with bee pollen. Maximal increasement was observed at 3.75 milligram per milliliter of sample, reaching 72%. The borscht drink sample was where I see the human cell fibroblasts. You can see that borscht enriched with the bee pollen had a maximal potential of concentration of the 15 micrograms per milliliter. That concentration is optimal for antioxidant activity because decreased antioxidant activity and can restore the homeostasis. In conclusion, by modulating the traditional beverage with the pollen, a multibiotic product is obtained with high antioxidant activity, a total phenolic content, total flavonoid, carbohydrates, and in the same time, you can stimulate the Lactobacillus growth with 15 to 18% compared with the positive control. In addition, at high potential for maintaining cellular viability with the number of viable metabolically active cells recorded in the beverage modulated by addition to pollen. Thank you for your attention.
Thank you to Andrea for this nice and complex work. If there are any questions.
Thank you.
Statements, but you measure, it's very nice because you measure what happens, but only small question, it changed a little bit the taste or not?
I want to try it. I tried only the sample borscht and it's
okay.
Good than the commercial one.
Nevertheless, very good results and congratulations because it's a scientific basis to put something inside.
Thank you.
To improve. Congratulations.
We'll pass to Popa Daria Gabriela.
Hello, my name is Daria Popa. I'm from Team 4 from ICECHIM, and today I will be presenting you studies regarding utilizing moving bed biofilm reactors for cultivating microalgae-based consortia and plant biostimulant production. In a short introduction, I would like to remind you how aquaculture wastewater can contaminate with nitrogen and phosphorus waters, which cause eutrophication. Also, microalgae consortia are known for treating wastewater, along with MBBR's technology, which can help to increase the efficiency of the treatment by providing an active surface that supports microorganisms involved in degradation processes. Now, our aim of the study was to develop an integrated biotechnology for co-culturing microalgal consortia employing moving bed biofilm reactors with the purpose of producing plant biostimulant while treating wastewater. As materials, we used the two species of microalgae, Chlorella species and Desmodesmus communis. Also, bacterial and yeast strains, part of them were isolated and part were from our collection of our lab. Moving bed biofilm reactors were provided by the FRS systems, which were used for co-culturing microalgal consortia with MBBRs for wastewater recycling. Further studies were quantifying biofilm formed on MBBRs and also formulating and testing the plant biostimulant. For selecting microalgal-based consortia, we used a high throughput screening, meaning we had to culture both yeast, bacteria, and algae. We used 96-pin stainless steel replicator, which was immersed in a 96 well plate containing the bacterial and yeast inoculum randomized. And the inoculum was immersed in another plate containing the microalgae inoculum. The plates were maintained in controlled conditions in an algatron, and the absorbencies and cell number was assessed after 7 days. The selected consortia was used for co-culturing microalgae with MBBRs for wastewater recycling. In order to do that, we used a synthetic aquaculture wastewater and 6 types of MBBRs, different in size and also in composition. Experimental variants included culturing co-culture with MBBRs, co-cultures, microalgal co-cultures without MBBRs, and also microorganism culture without MBBRs as controls. In this experiment, we measured both the microalgae growth parameters and the water quality parameters. Optical density, turbidity, and cell number as microalgae growth parameters, and chemical oxygen demand, biological oxygen demand, and water pH for water quality parameters. All this data was subjected to the statistical analysis in Design Expert. For biofilm quantification, we first cultured the first types of MBBRs 1 and 2 for 30 days. Then for biofilm fixation, we use formalin solution. We washed with sodium chloride and then stained with crystal violet solution, rinse with water, and the absorbance of the solubilized crystal violet was measured at 590 nanometers Indica spectrophotometer. Also, gravimetrical quantification was done by weighting the MBBRs before and after the first measure, the first analysis was done. The excess biomass of the selected consortium was used for plant biostimulant formulation. Sorry, I forgot to mention that because both biofilm quantification, water recycling, and all was sorry, my bad. Excess biomass of selected consortium was used for plant biostimulant formulation. In order to do that, we ultrasonicate the biomass for cell disruption. We tested 2 concentrations of 4 milliliters and 8 milliliters per pot, meaning 4 and 8 milligrams per liter. 3 physiological parameters of the plants were measured. Now results, finally. We selected 7 strains of bacteria and 2 strains of yeast for the study, basically for the high throughput screening. the molecular identification of the optimal isolate, which I will talk about later, was performed based on ITS region by DSM in Germany. Now, results regarding H2 screening showed us a NeXT strain that enhanced microalgae growth the most for chlorella species. So this is the strain selected for further studies. For Desmodesmus communis, we selected the bacterial strain, being the one that enhanced growth measured by cell density and also optical density. When culturing microalga cultures for wastewater purification, we first measured growth parameters of microalgae, and in this case, chlorella co-culture recorded the highest values, both for optical density and cell number. Regarding the MBBR, which recorded a higher growth for microalgae consortia, resulted to be MBBR 1. Next, water quality parameters start from 92 milligram oxygen per liter of chemical oxygen demand, which all these results are after 3 days of culturing. This increased up to 86% the chemical oxygen demand, and also biological oxygen demand being in the same trend. This time also chlorella co-culture recorded the lowest chemical oxygen demand, being our purpose of the study. All this data being subjected to design expert analysis allowed us to discover the most desirable and the least desirable. So the chlorella and NeXT consortium, along with the first type of MBBR, showed seemed to be the most desirable, meaning the highest growth microalgae parameters and the lowest chemical oxygen demand, the highest purity water levels. So this was the consortium that was further used for biostimulant formulation and testing. Biofield quantification also pointed up to the first type of MBBR more than for the second. The first time of the first type has no cellulose in it, and the second one has 3% cellulose, and that can be a cause of unattached biofilm or less attached biofilm on the second type. Because chlorella and yeast proved to give the best results in terms of microalgae growth and the biofilm formulation and the water treatment, the recovered biomass was chosen to form the plant biostimulant and tested on cucumber plants. I have to mention here that this yeast strain was identified as Rhodotorula mucilaginosa. Regarding physiological parameters of the plants, before treatment and after 6 days of the treatment, transpiration rate and photosynthetic rate was higher for the lowest concentration of 4 milligrams per liter, while chlorophyll fluorescence was the same for 4 milligrams per liter, and the stomatal conductance was higher for the lower concentration tested. In conclusion, using the high throughput screening technique led us to select 2 microalgal consortia, first with chlorella and yeast, and the second Desmodesmus and bacteria. Yeast co-cultured in Chlorella consortium was identified as Rhodotorula mucilaginosa. When co-culturing microalgae consortia with MBBRs, Chlorella Rhodotorula consortium recorded higher values for growth parameters, meaning more biomass and lower chemical oxygen demand in the synthetic water up to the detection limit of the analysis. The biofilm development was higher on MBBR1, which does not contain cellulose than the second type, which had 3% cellulose. And the biostimulant based on Chlorella rhodotorula was applied on cucumber plants. The highest chlorophyll fluorescence and photosynthetic rate were recorded with the lower application concentration. The higher tested concentration led to a significant increase in stomatal conductance and respiration rate of cucumber plants. Thank you for your attention.
Congratulations, Gabriela. If there are any questions? No? If no, thank you again.
Thank you.
And we'll move to Bredfeld Elisa Gabriela with understanding water impact on the thermal behavior of deep eutectic solvents, insights from PGA analysis.
Hello, and thank you for the nice presentation. Today, I will be presenting you our study about understanding the water impact on the thermal behavior of deep eutectic solvents, from a thermogravimetric analysis. Deep eutectic solvents are the green class of solvents from the ionic liquids. They are formed through hydrogen bonds between a hydrogen bond acceptor and a donor. They are formed by large asymmetrical ions with low grid energy, resulting low melting temperature, and so the appearance of the eutectic point. For this study, we have used two deep eutectic solvents. The first one, the Relin, composed by choline chloride as the hydrogen bond acceptor and urea as the hydrogen bond donor. The second solvent used the same hydrogen bond acceptor, choline chloride, and the donor this time was ethylene glycol. Both solvents had the molar ratio 1 to 2, hydrogen bond acceptor to hydrogen bond donor. The aim of this study was to unveil the role of water in thermal properties of these two solvents through comprehensive thermogravimetric analysis. We have used from 5 to 60% water content for each solvent in order to study the thermal behavior, a critical role in determining their utility. In the first thermogram, we have 4 steps for the ethylene. In the first step, from room temperature to 105 degrees Celsius, the water has evaporated, has left the system. In the second, and also traces of ethylene glycol. In the second range, ethylene glycol has started to leave the system through intermediate acids as glycolic acid and formic acid. In the third step, ethylene glycol fully leaves the system and choline chloride starts also to degrade. As we can see in the residue column, all the solvents were fully degraded. In the Relin, we have here 3 steps. Firstly, the water leaves it. Then the urea is more stable. And also it degrades in the third step, also with the choline chloride. Another analysis was the density using a densimeter method from Method Toledo. As we can see, the density of both solvents slightly decreased with the increase of water. The next analysis was the surface tension using the tensiometer from data physics. In the case of ethylene, we see in the first 5 samples a quite similar value, around 55 millinewtons per meter. And with the water raising concentration, we also have raise in the surface tension. In the case of Relin, we have a decrease of surface tension with the increase of the water content. The last analysis was the contact angle. The first one was on the hydrophilic surface. Ethylene, we see a decrease of the contact angle from 37 to 26, meaning an increased hydrophilicity. Also, an increased hydrophilicity with the increase of water was in the case of Relin, but with a more faster step. In the second surface, the hydrophobic surface, at ethylene, we see a slightly increased hydrophobicity with the increase of water, but in the case of Relin, we see a decreased hydrophobicity with the increase of water. Conclusion, higher water content leads to alteration in thermal degradation pathway and surface characteristics, highlighting the importance of understanding water's influence on both deep eutectic solvents. While at lower water concentration is a better thermal stability, at higher water content, the stability decreases and alters decomposition's kinetics. Contact angle measure indicate shift from hydrophobic to more hydrophilic behavior as water content increases. Throughout our study, the eutectic nature of both ethylene and Relin remains evident. Despite variation in water content and thermal behavior, the characteristic properties persist, emphasizing their potential for further applications. Thank you for your attention.
Thank you, Eliza. Questions, anyone? From online? Thank you again.
Thank you.
And now we invite Ciobanu Livia Teodora to present us her work.
Hello, my name is Ciobanu Livia. I'm a research assistant in Group 4 here at ICECHIM, and I am glad to present to you today our study on sodium selenide effects on Saccharomyces cerevisiae yeast cell growth and how this compound triggers calcium-dependent responses in these cells. I find the history of selenium quite intriguing. It was discovered by Berzelius in the first part of the 19th century, and it was labeled instantly as a toxic element. It wasn't until almost a century and a half later that two researchers, Schwarz and Foltz, reported that selenium is not only toxic, but it is also essential. Since then, selenium has been recognized as a micronutrient, which means it is essential for maintaining homeostasis in humans and animals. Today, we know that selenium has strong antioxidant activity and immunomodulatory effects. However, there is an issue that still remains. There is a fine balance between selenium toxicity and deficiency. Therefore, finding the ideal form of selenium became a hot topic, and the research on this area over the last decades have established that zero-valent selenium is the least toxic form of selenium available. The natural world seems to provide some fascinating answers for us, as usual, but this time on producing selenium alternative, which are superior. Microorganisms, bacteria, fungi, yeast, have the capacity to reduce selenide species and to produce zero-valent selenium nanoparticles. These biogenic selenium nanoparticles are less toxic and much more biocompatible than inorganic forms of selenium. Not to mention that this biosynthesis is also environment-friendly, and the resulted nanoparticles have enhanced biological activity and also enhanced stability. The aim of our work was to study the effect of a selenium precursor, sodium selenide, on Saccharomyces cerevisiae cell growth, and to highlight some potential mechanisms on which might be involved in selenium nanoparticle production and selenium reduction in yeast cells. To provide a more comprehensive context for presenting our study, I'm going to state out first that calcium ions are known as secondary messengers in cells. They are involved in crucial processes such as cell division and cell apoptosis, but they have also been connected with the cell response to certain factors of stress. We have noticed that some Saccharomyces cerevisiae calcium-defected mutants react in a certain way in relation to sodium selenite. So our study focused on Saccharomyces cerevisiae wild-type strain and free mutant strains which lack a certain gene that codes for a specific protein which acts as a calcium channel in yeast cells. To be more precise, for example, the CCH1 knockout or mutant strain has had deleted the CCH1 gene and therefore lacks the CCH1 calcium channel. The other two mutants were modified in the same manner, but lack the MID1 genes and the YVC1 genes and therefore the corresponding calcium channels. To assess the sodium selenite effect on the growth of Saccharomyces cerevisiae yeast cells, we have serially diluted the culture of each strain in a microplate, and then we stamped the culture on a YPD agar media, which was supplemented with sodium selenite in a range of concentration from 0.5 to 4 millimolar. One of the first observations is that the culture changed their color, which means that selenium was indeed reduced. How do we know that? The cultures turned red, which is an indicator of selenium nanoparticles presence. The second observation would be that the growth of these strains was severely inhibited in concentrations exceeded 2 millimolar sodium selenite. But even more interestingly, the MID1 knockout strain was the most affected by the exposure to sodium selenite, which means that yeast cells might need the MID1 calcium channel to survive the sodium selenite-induced stress. The YVC1 knockout strain was the most resistant one. It is also interesting to mention that CCH1 channel often colocalizes with the MID1 channel, and this was one of the sensitive mutants as well. Therefore, the cells use these two channels to cope with sodium selenite-induced stress. The mutant strain were also grown in liquid YPD media in the presence of sodium selenite over a period of 24 hours. After these 24 hours of incubation, their optic densities of the culture were measured. The values were represented graphically in relation to sodium selenite concentration. These results confirm the previous one. The growth of MID1 knockout strain drastically decreased at high concentrations of sodium selenite, or relatively high concentrations exceeding 1 millimolar to be more precise. And the YVC1 knockout strain was indeed the most resistant strain. To understand better the response of calcium-defected mutants to sodium selenite exposed yeast cells, we assessed the effect of supplemental and deficient calcium on yeast cells exposed to sodium selenite. Meaning that we again serially diluted the culture of each strain and stamped it on agar media, this time on synthetic defined media, enriched with sodium selenite, but also with calcium or EGTA, which is a calcium chelator and therefore creates a medium deficient in calcium. The most interesting conclusion drawn from this experiment was that the YVC1 strain preferentially grew on the calcium enriched media, while on the same media, the CCH1 and MID1 knockout strain were severely inhibited. This means that yeast cells prefer to mobilize external calcium sources in favor of, for example, internal calcium sources from the vacuolar channel YVC1. They mobilize this external calcium sources and transport the calcium through CCH1 and MID1 calcium channels. We have assessed the influence of sodium selenite on yeast cell growth over a period of 6 days through optic microscopy. And the images we have obtained offered us also some intriguing results, showing that after the synthesis of selenium nanoparticles, after the selenium is reduced, the nanoparticles have a tendency to bind to the plasma membrane, and they are slowly absorbed intracellularly. It is probably a phagocytosis process that is happening here. Both sets of images prove this, but they also prove that selenium nanoparticles accumulate inside yeast cells. In the second set of pictures, images B show the media in which yeast cells were grown, where selenium nanoparticles can be observed as well. So yeast cells can also synthesize external selenium nanoparticles. We have selected the most sensitive MID1 strain and the most resistant YVC1 strain to obtain some SEM micrograph. Scanning electron microscopy of this strain grown in media with and without selenite showed that in the presence of sodium selenite, as we have seen before, these cells form indeed selenium nanoparticles, which can be seen here in picture B and D as those tiny white spots. The wild-type yeast cells were assessed through transmission electron microscopy. We confirmed once again the presence of selenium nanoparticles on the surface of the cell. But here it would be recommended that we optimize this method with a fresh biological sample next time for a more precise localization of the nanoparticles. We have tried to find out if there is a way to preserve the selenite reduction, but also to mitigate the potential unwanted effects on yeast cell growth. And so we assess the effect of some antioxidants on sodium selenite exposed cells. We started with vitamin C. We added vitamin C to a sodium selenite enriched media. And when we prepared these agar plates, we have noticed that the addition of vitamin C has instantly reduced our selenium precursor sodium selenite, and therefore the media turned red. It is obvious that the influence of vitamin C was benefic for yeast cell growth, as the yeast cell growth increased in the media supplemented with vitamin C in comparison with the media without vitamin C. So we proceeded to test other antioxidants too, such as dithiothiotol and N-acetylcysteine. And we have added each of these antioxidants to wild-type yeast cell cultures in the presence of sodium selenite, of course. And we have measured the optic densities of these cultures over every 2 hours over a period of 24 hours. The values were graphically represented in relation to the time of exposure, and the concentration of sodium selenite that was used is specified next to each graphic. And the first important conclusion would be that N-acetylcysteine had the most protective effect on yeast cell growth, even at high concentrations of selenite, although its effect decreases with the increase of sodium selenite concentration. But in comparison with other antioxidants, it is more protective. Also, it is interesting that the thioetriol first decreases its protective effect, but at higher concentrations of selenite begins to grow its protective effect on yeast cell growth. I thank you for your attention, and I leave you with this scientific food for thought, which I strongly resonate with. Thank you. If there are any questions.
Thank you for these nice results. We are waiting for questions. No? Okay, thank you again.
Thank you.
We'll pass to the last presentation of this second plenary session with Bala Ioana Alexandra, modulation of rice husk biodegradation by Trichoderma atroviride irradiated with blue laser light, a scaled-up attempt.
Okay, so hello. Today I will present few considerations concerning the modulation of rice husk biodegradation by Trichoderma atroviride irradiated with blue laser light, a scaled-up attempt. The environmental conditions like level of oxygen, temperature, humidity, and the concentration of reactive oxygen species can differ in soil and on the crust surface. These properties can also change during day and night. Fungi develop the ability to adapt to the ever-changing environment in order to survive. One important factor is light, which can regulate morphological and physiological processes of fungi and the expression of some enzymes like the lignocellulosic ones. Light, especially in the blue regime, influences signaling pathways affecting the metabolism, stress response, and development of fungi. Our research delves into the impact of blue laser light irradiation, a less conventional form of illumination, to the bioconversion of rice husk by Trichoderma in an attempt to scale up the process. The strain that we used was represented by Trichoderma atroviride. Fresh mature spores from ICECHIM medium was used to stimulate the production of biomass degrading enzymes and were supplemented and were cultured into water supplemented with rice husk in 2-liter flasks for 15 days at 28 Celsius degrees. The samples were exposed 3 times to blue light laser for 60 seconds each at a specific intensity in different days. All the flasks were kept into the dark throughout the experiment. The supernatant was used to assess the enzymatic activities, the soluble silicon, the polyphenolic content, antioxidant activities, interfacial tensions, and contact angles were made as well. Moreover, microscopical features of mycelia were evaluated. The degradation of rice husk was visualized by SEM, and SPSS software was used for statistical analysis. Exposure to Trichoderma atroviride to blue light was observed to impact the enzymatic activities. The highest cellulase and protease activities were observed after the 3rd irradiation and were higher than the non-irradiated one. The MLS and LPMO activities were not significantly affected by blue light. The soluble silica from the culture was determined at the end of the experiment. Figure 2 shows that Trichoderma atroviride released a significant amount of soluble silica from rice husk, both into the irradiated and non-irradiated ones. The soluble silica from the culture media was increased after 3 irradiations compared to the non-irradiated one. The polyphenolic content had a heterogeneous behavior. As we mentioned before, Trichoderma atroviride is involved into the breakdown of the lignocellulosic matrix from rice husk, leading to the release the phenolic compounds into the growing medium, and the increase in phenolic compounds or content following irradiation show an intensification of the breakdown process. The antioxidant activity had also a heterogeneous behavior. Irradiation induced a decrease into the PUFRAP and CUPRAC activities compared to those who were not exposed to the blue light. This may be a fact or a consequence or oxidative stress triggered by irradiation. This stress can lead to the generation of free radicals and ultimately leading to a reduction in the concentration of antioxidant compounds present in the sample before irradiation. More depth studies are needed to confirm this hypothesis. The blue light decreased the surface tension and the contact angles of the samples. The contact angles on a polar surface were smaller than those obtained on a non-polar surface, giving an amphiphilic nature of the samples. Here we can see the morphological aspect of the non-irradiated and 3 times irradiated Trichoderma atroviridae. Exposing the samples to blue light increased the production and the diameter of conidia in irradiated samples compared to those who were not. And these results are statistically significant. SEM micrographs revealed an intensified lignocellulotic matrix deconstruction due to Trichoderma atroviridae exposure to blue light laser, figure 8C and D, compared to those who were not irradiated A and B. In conclusion, our findings suggest a rise in enzymatic activities of Trichoderma atroviridae upon exposure to a moderate intensity of blue laser light for 60 seconds. The increase of soluble silica content in the medium after irradiation indicates an enhancement of the breakdown process. And the irradiation enhances the sporulation of Trichoderma and changes the cohesion and adhesion forces of the growth medium. And thank you for your attention.
Thank you to Ioana. Any questions?
Okay, so good afternoon. In the end of this day, I will invite Mrs. Naomi Tritean to present her work entitled Plant Biostimulant Effect on Rice Husk Nanobiosilica Embedded in a Film Forming Formulation and Apply Seed Coating. So good luck.
Hello, everyone. My name is Naomi Tritean, and today I will talk about blunt biostimulant effects of rice husk nanobiosilica embedded in a film-forming formulation and applied as seed coating. It's well known that to ensure a suitable environment for seed growth and development in the context of climate change is a crucial aspect to reduce the harmful effects of different abiotic stresses, which are amplified by the climate changes. So mitigation solutions in order to reduce these negative effects in agriculture are needed. So the aim of this study was to obtain a seed coating formulation made of alginate glycerol and sorbitol with embedded nanobiosilica recovered from rice husk, which is a rich source of silicon. Silicon is not a nutrient for plants, but mainly a microelement with beneficial effects. And there are two roles of silicon that are known in plants. One is physiological, associated mainly with the silicon translocated in plant by symplastic root. Another one is structural or mechanical, associated mainly with the silicon translocated by the apoplastic route via LSE2 transporter. So this is the schematic flow process of silica nanoparticles recovery from rice husk. As you can see from dilute acid hydrolysis, from the dilute acid hydrolysis of native rice husk, it was obtained a black powder due to the hydrocarbonization process, and after calcination we obtain the white powder due to the thermal carbonization of the lignocellulosic biomass. Afterwards, we determine the total silicon content of rice husk and final product by ICPOS, and it was an increase in the silicon content after calcination in comparison with native rice husk. By X-ray diffraction analysis of native rice husk intermediates and silica nanoparticles, we observed that in native rice husk, silica, triclinic silica, sorry. Triclinic silica coexist structurally with amorphous silica together with cellulose 1-alpha, 1-beta, and amorphous cellulose. After the hydrolyzation process, triclinic silica is decomposed or solubilized with other thermally susceptible compounds like hemicelluloses, proteins, and after calcination we can see only the peak at 22 degrees for amorphous silica. With respect to crystallinity, it was an increase in crystallinity after the hydrolysis process from 66% in native rice husk to 87% in hydrolyzed rice husk, and in calcined rice husk, which are our silica nanoparticles, only the crystallinity was only 2%. From FTIR analysis, we can see native rice husk colored in green, the amide 1, 2, 3 protein bands, as well the carbohydrates bands. And after the calcination, we also can see that the silica nanoparticles are characterized by the COC and CO bond vibrations. Then we performed the beta analysis. We can see that the absorption isotherm has a hybrid aspect with isotherm 2 combined with 4A. The elements for isotherm 2 can be seen at the extremities, describing the monolayer absorption limit, and the elements for isotherm 4A are described by the hysteresis loop, describing therefore the monolayer absorption combined with capillary condensation in cylindrical mesopores wider than 4 nanometers. After the pore size distribution analysis, we can see an interval between 2.5 nanometers and 50 nanometers, almost Gaussian centered at 5 nanometers, with a majority of pores less than 10 nanometers. Quasi-spherical silica nanoparticles of about 50 nanometers were observed by TEM analysis. The STEM module allowed us to achieve a linear profile of 50 spectra that can be summed up to give a global spectra of the analyzed area. And we can see that the main elements are silicon and oxygen, and there are no major variations, resulting that our nanoparticles are homogeneous. And also, you can see that our nanoparticles were mostly agglomerated, so a stabilizing process and agent was necessary. So we dispersed them in alginate, and we can see that the alginate between the silica nanoparticles partially prevents their agglomeration. Afterwards, by SEM analysis, there was a reduction in the amount of organic matter as well as the reduction of particles after calcination from about 200, 100 micrometers to less than 50 micrometers after calcination. Also, by dynamic light scattering, we have 3 major populations between 85 nanometers and 515 nanometers. We also want to assess the release of soluble silicon from silica nanoparticles, and we can see that the soluble silicon is released day by day constantly during the 4 days tested, and that the ultrasonicated nanoparticles release more soluble silicon than the non-ultrasonicated ones. Then we optimized a seed coating using design expert software and dynamic mechanical analysis, and based on traction tests, we obtain young modulus and ultimate tensile strength. And then for the optimum seed coating, we minimizing young modulus and maximizing ultimate tensile strength in order to obtain the most elastic film, but which have also the higher ultimate tensile strength to be good for seed-to-seed impact, because the seed coating was achieved by bottom spray process. And as you can see, we obtained by SEM analysis a homogeneous film with or without silica nanoparticles. And based on EDX analysis, the main elements are silicon, carbon, oxygen, and sodium. The film it has about 11 micrometers. Then all the assays that we performed on mung bean seedlings were achieved in the absence of salt stress and in the presence of salt stress. Therefore, we want to assess the silicon content from mung bean seedlings. And as you can see, in general, the silicon content is higher for the seeds treated with AGS with embedded silica nanoparticles, but it's not a linear concentration, and it not depends on the silica concentration. Therefore, absorption of silicon in mung bean seedlings is merely not a passive process, but an active process which requires some mechanisms for transportation. Then we assess the plant height and alpha amylase activity to assess plant growth and development. And you can see that in comparison with uncoated mung bean seedlings, the AGA's coating increased the plant height, as well as the AGS film with embedded silica nanoparticles. And this effect in the presence of salt stress is only marginally significant. Alpha amylase is important for degradation of starch for metabolic energy, but neither salt nor film had a significant impact on the alpha amylase activity, but we see a tendency to increase the alpha amylase activity in the presence of 2 and 3% silica nanoparticles embedded in the AGS film. Therefore, we assess the photosynthetic pigments, and as you can see, it's an increase both in chlorophyll content and carotenoids content, more obviously in the presence of salt stress and in the presence of AGS with embedded silica nanoparticles. Then we want to assess the metabolic activity on mung bean seedlings, and we perform the proton pump assay. As you can see, the gel is purple in neutral pH, and when the pH decreases, you can see a yellow area around the root. And then we perform the image analysis to calculate the specific extracellular proton level. And as you can see, in the absence of salt stress, the AGS formulation decreased the specific extracellular proton level, but this effect is counteracted at the highest concentration of silica nanoparticles, 3 and 4%, and you can see an increase in the presence of salt stress for 1 and 2% silica nanoparticles. A similar pattern is observed for MTT reduction, which is a marker of mitochondrial enzymes. Then we studied the reactive oxygen species metabolism in mung bean seedlings, and we assessed the hydrogen peroxide content. As we expected, the highest content of hydrogen peroxide was found for the uncoated mung bean seedlings in the presence of salt stress. Then it was a decrease in the presence of AGS coating and a further decrease with embedding silica nanoparticles. We also assessed the lipid peroxides in the cell. with respect to MDA content, which is a product of peroxidation reactions that occur at cellular level. And as in the case of hydrogen peroxide, the highest content of MDA was found in the presence of salt stress in the absence of coating. Afterwards, we can see a decrease after the AGS film and a further increase after including silicon nanoparticles in the AGS coating. In the absence of salt stress, the effect was not so significant. Therefore, we studied some key enzymes involved in the antioxidant defense system, like superoxide dismutase activity, catalase, guaiacol peroxidase activity, and glutathione reductase activity. In the absence of salt stress, the superoxide dismutase activity is relatively constant, and we can see an increase by increasing the silica nanoparticle in the AGS film in the presence of salt stress. Then we can see a decrease after the AGS coating in the presence of salt stress for catalase activity, but this effect is counteracted by the 2% silica nanoparticles embedding in the coating. Therefore, the same pattern as in the case of superoxide dismutase activity was observed for guaiacol peroxidase activity, and for glutathione reductase activity, which is mostly a marker for activating the glutathione ascorbate cycle. We can see that in the absence of salt stress, there is an increase in the glutathione reductase activity by AGS film, followed by a decrease by embedding silica nanoparticles, and the highest glutathione reductase activity was found in the presence of salt stress for uncoated mung bean seedlings, followed by a reduction by AGS coating, and a further decrease by at the highest concentration of silica nanoparticles, respectively 4%. Nitric oxide is important for activating different defense pathways mechanisms in plants in salt stress. So as you can see, even in the absence of salt stress and in the presence of salt stress, it is an increase in the nitric oxide content, and the L-proline content, which is an osmoprotectant. It was a decrease, followed the AGS film, and the further decrease followed the addition of silica nanoparticles in the coating. In the absence of salt stress, the content of L-proline is relatively constant with no differences between the experimental variants. We also assessed the reactive oxygen species accumulation in mung bean seedlings, and based on fluorescence microscopy images, we performed image analysis to quantify mean fluorescence intensity, and it is the same pattern as in the case of MDA content. The highest level of reactive oxygen species was found in the uncoated mung bean seedlings, and it was a further decrease after the AGS film and after embedding silica nanoparticles in the film, and in the absence of salt stress, there are no variations between the experimental variants. So we also performed the Pearson correlations to assess all the significant correlations between all tests that we performed, and we observed some significant correlations in terms of increasing plant height and increasing in the same time photosynthetic activity and alpha amylase activity, as well as some activity of key enzymes, and decreasing reactive oxygen species, MDA content, and L-proline content, as well as hydrogen peroxide. So in conclusion, our first silica nanoparticles of about 50 nanometers embedded in an alginate glycerol sorbitol film were obtained, and this process of coating was achieved by bottom spray process, resulting in a homogeneous film that resulted also in the alleviation of salt stress on mung bean seedlings. And we believe that our data will have not only scientific, but only important economic and social implications. And we also think that it is important to continue to investigate the effects of our tested formulation in real life conditions such as greenhouse or field, and to possibly have multiple stress forms, and to also investigate in the future the mechanisms of our tested formulation at molecular level. Thank you.
Oh, thank you, Naomi, for this nice presentation with interesting results. If there are any questions from audience or from online, we'll pass to Mr. Pshevnovsky. Grigore.
We live in society where technology is already a part of our life. So most of us have smartphones, tablets, PC, and we have access to the information anytime, anywhere. So for this presentation, I was inspired by an amazing presentation made by Bogdan Trip. Bogdan? So I got an idea to combine my two passions, the passion for science and passion for video games. So what's the result of this? So ladies and gentlemen, welcome to the science-inspired action games presented by Grigory Pshevnovsky. So first of all, I will start with the influence of video games on science. I'll try to be short, don't be scary, that's a lot of text, but cognitive skills enhancement such as perceptions, spatial awareness, problem solving, decision making, multitasking, and stuff like that. STEM learning. STEM is science, technology, engineering, and math learning. It's enhancing the study that using digital games can often reinforce and expand on academic content. Citizen science participation. Now, I'll be more detailed on this. So everyone remember the time of 2020, the COVID, the lockdown, the problems with the working. So there is a project Discovery, the game EVE Online, where researchers tried an experiment where players tried to making these triangles batch mini games where they make these forms, but the players gained some experience, some coins, but not this. You gain this feeling when making these games, and these results are sent to real researchers. So these activities reduced 30 years of research for cure of COVID. So next one is data analyzing and problem solving, such as climate change and behavior of fluids. Next one is innovation and creativity, such as graphics, artificial intelligence, and user interface design, such as this presentation you'll see next. And the last one, collaborative research projects. So big companies or research institutes collaborate with some game companies. So, ladies and gentlemen, our journey to science starts with the main menu. The fate of this presentation is in your hands. Please make a choose which chapter you want to start. Please, don't be shy. More opinions, more, please. 2, game inspiring experience. Thank you. So, I'll begin with a story. my story our story begins with a game called Return to Mysterious Island. The game is a graphic adventure game. It's made by it's a game based on Jules Verne's novel, where Mina, our main character, is a shipwrecked woman forced to survive on an uncharted island. But during the game, there is a chapter called Chemicals and Weapons. So Mina, our main character, found an abandoned house, and in this house found a diary. So this diary is instructed how to make a becquerel battery, volta battery, nitroglycerin sulfuric acid, and gunpowder. So here you can see the list of all chemicals that you can make in this game. So the next one is an example where we take a boiler, a tank, and a coil. We combine all these things, and we obtain a distiller. So now we need fire for this distiller. So combine again, we gain a lighter, and we obtain the fire. Using the fire, we during our exploration, we have maple syrup, so we obtained alcohol. So now you're asking, what's the point of all of this that I was presented? The point is that this goddamn kid, as a 10-year-old boy, discovered how to make dynamite, nitroglycerin, and batteries in all this game at the 10 years old. There is also an interesting story. When I was playing this game, Mom, what is sulfuric acid? Mom, what is nitroglycerin? How to make this all? I was very lucky that my mom was a chemical teacher. So all this influence, all this game, all this help, it was a result into becoming scientific research. So now, we are back to our main menu. Please make a choice. What you want to listen next? Video. Are you agree all? Video. Fine. So, we have a video contest. Your task is to which from these videos is not AI generated, is not made by artificial intelligence. So you have 4 videos. I give you 30 seconds to guess which one. It can be a TikTok video, it can be a YouTube video, it can be everything. The time is over. The time is over. Please, someone, your guess, which video is not generated? No, you know. You know which video is not AI generated.
The fourth one.
Which video is not AI generated?
Last one.
A, B, C, D. Which one? D. D.
C.
You know.
The second one, B, is not there.
One more opinion. Mr. Andrian, your opinion?
D.
Congratulations. The variant B, it's not AI generated. Applause, please. I'm sorry, we have a little bit of problems. We have some technical problems. So, thank you. We are back to our presentation. So, as was presented, the variant B was the correct one. So now So I want you to look again at these videos, but from other perspective, knowing the answer. So all these videos that you see with the red was a prompt or a text that I input, I made this text, and AI generated these videos. So now I want to present something really interesting, revolutionary. So Sora is an innovative video generation technology developed by OpenAI. So, you know, ChatGPT, I know you all using ChatGPT. It utilizes advanced machine learning algorithm to synthesize realistic and high quality videos from textual descriptions. So you introduce the command, the prompt, and this technology generates you these videos. So I want to warn you, this technology is still young, it's still in development, but the internet, it's interesting place. The more you search, the more interesting in the funny objects you find. We are back to our menu. So last one is discover, learn, and play. So, okay, we are starting with this. Please raise your hand who is learning or in future want to learn a new language. Please raise your hand who is learning a new language. No one wants to learn a new language. So I have a solution for you. Duolingo is a user-friendly language learning app where you can learn a new language at their own place, anytime, anywhere. It offers a wide range of languages to choose from: English, Spanish, French, German, any kind of language. I will never forget your learning German, coffee and milk. It will follow me anywhere. So it incorporates a variety of learning modes, including speaking, listening, reading, and writing, to cater to different learning preferences and styles. So after using 4 to 6 weeks, so I found this publication. After using 4 to 6 weeks of this application, you are ready to speak with the other people and use this new language that you learn. Я вас очень уважаю и поддерживаю, что вы используете дальше этот язык. So it means I encourage you to use this new language and application. So our next guest is Pymol. So Pymol, so Polymer department, hello. Pymol, it's app that visualize polymers, ADN, proteins in 3D structure. It have a widely used in biology, biochemistry, and the related fields. A lot of platforms, a lot of options, open source, commercial version, based on what you need. So our next guest, I'm sorry that there is audio, but you can listen because of this microphone. The game starts with just a few basic elements, and through combination, inspiration, some creativity, with the combining of the elements, you obtain a different element. So we have this spirit of chemists. So this is your opportunity to test something new and create something new. So my next one is a code combo. If you are inspired to be a programmer, IT department, hello. It covers, so the logic of this game, every action, every movement, everything is made but your own code. You write the code and this character make this action by your written the code. So it covers a lot of languages. Python, JavaScript, Pikachu, Me2, Ditto, and stuff like that. So my next one, this is the interesting one. I was really very interested in this one. It's a platform developed by University of Colorado Boulder. It's a free online platform where you know the basics of the science, biology, math, chemistry, physics, and stuff like that, as you can see in this video. So I'm really interested, and I hope in the future someone will implement this simulation to the school, colleges, and stuff like that. So we listen everything from here. I'm sorry, just a minute. So we listened everything from here, but I still have some tricks in my sleeves. So you unlocked a new hidden slide. So there is a final part. You don't have any choice. I make this choice. So at every end of the section, we have Q&A section. But I turn the roles against you. What's the purpose of this presentation? Why I am making this? Why you are listening? Any opinion? I encourage you, any opinion, any idea. You don't need to be something philosophy. Oh.
Okay, as I'm pretty sure you generated your presentation with artificial intelligence, maybe it's an example, and you could tell me what program did you use? Maybe not to, okay, no?
It's not nothing generated. Only generated things here are the videos. That's the only one. Any other opinions? Any other opinions? Okay, so I will start with the motto: science without society is lame, and society without science is blind. So what does it mean? Pros and cons using NI. It's really interesting thing that we all use ChatGPT, so it's new innovation. It's we have a problem, we are using how to resolve this problem, how to make it. So ChatGPT help us. Okay, we have the answer. Repetitive job, we have some data to proceed, to make this data faster, to proceed this information. So okay, AI help us, data acquisition and analysis. But from all of these pros, we have some interesting cons. Making human lazy. The more we are using AI, the more we are lazy. Okay, my work will make the ChatGPT again or other AI. Okay, less human interaction. We simply addressing to bots, to robots. We often talk with some that we can't see, and the interaction between people and people are becoming more petty, and it's kind of sad. Unemployment, also it's an interesting one, because we know that AI can create images, as you saw, videos, and some of them jobs are also disappearing, like designers, like architecture, and other jobs. So my goal of this all was the connecting discoveries and everyday problems and solutions. the bridge between science and society. So we all know that kids nowadays I want to be a TikToker, I want to be a YouTuber, I want to be an influencer, but there are less hope. In my time, kids and even me wanted to be a fireman, a policeman, scientific, something. I want to be a president. But nowadays, kids want something different. So my also was interactive learning, creating engaging apps and games centered around fundamental science principles, where you have a lot of platforms, simulations, games, as I presented here, where is science-based, where you learn science, chemistry, physics, and stuff like that. So use research-based teaching methods and liveful content to create a learning science that deliver results. So at the end of all of this, one person said, I put my soul in one of my presentations. Ana Maria Curban, if you are watching this, thank you very much. In this one, not only my soul, but all parts of my life.
So thank you, Grigore. It was a dynamic, interactive, and quite different presentation. So if you have any remarks or something to add, Mr. Serbo?
I want to congratulate you. It was very, very nice, your presentation.
Thank you very much.
And even in this manner, you put important problem to think about. And my question is about artificial intelligence. You know that now there are some program which can to write an article. You give some data and he will write the article. And
Yes.
you can publish this. Do you think that from the ethical point of view, this is correct or not?
It's kind of hard to depistate or to find which article is AI generated or not. But I read an article where OpenAI that created ChatGPT want to make a Turnitin application, like Turnitin application, where this application can detect which text is AI generated and which is person made. So it's still, again, it's in development. It's kind of really hard to depistate which is robotic or which is human. But if you know your student or co-worker, you know the style, how he express his thoughts. So when you're reading something, you can depistate his ideas or thoughts, or how he thinks. There is kind of tricky thing. I'm sorry, really, this presentation is not AI generated. The only was video. I put 3 weeks of work to entertain to make this presentation. Microphone.
So I just wanted to add a little thing just before you put a question. There is a possibility that soon enough, using AI, we will be able to detect which article is written by AI and which is not. I think it's quite possible.
Thank you. Interesting presentation, very humoristic. It's a nice and to be happy this weekend. And now to answer to Dr. Serbu, nature set are not acceptable for a very simple intellectual property problem, because it's not traceable from where it comes, because artificial intelligence don't tell you the source. And that is not possible in science, not to be traceable. Okay. Sorry? Congratulations, very good start, very humoristic, and we should discuss in the future. Also, we prepare something. See? Thank you.
Thank you, Grigore.
Thank you. Thank you. I love you all.
I have also a question. I raised the hand, Ana Maria.
So we are closing this session with Mr. Andrei Sârbu from the side of Romanian Chemical Society. So please start.
So we are sorry for the small delay. It seems like we are having some technical issues. I take advantage of this small interruption to thank the Ministry of Research, Innovation and Digitization. I think those 2 days you've heard about the research grants for young researchers. Those were implemented in our research, in our project financed by the ministry, supporting the competitiveness and excellence of ICECHIM research and innovation in the area of bioeconomy and related fields. A project funded under the call Projects for Funding Research Development and Innovation Excellence. Also, many of our colleagues presented works that were supported by the ICECHIM core project, Sustainable Development through Advanced Chemistry for a Circular Economy, Chem New Deal. It's aligned with all the European trends. So we would like to thank with this opportunity, to take this opportunity to thank the Ministry of Research for all the help. And we do hope that in the near future, this approach to promote young researchers, to allow them to see what a project means, how can they implement it, and to have the responsibility in the same time of results and practically all the stuff that we know that it means a project implementation to continue in the next call. From what we hear, we hope that this year will also be a call for projects for financing excellence. I do hope that I will not have to keep you talking for too long. But if we are having some blank time, I would also like to thank my colleague Bogdan Trică, who held the fort yesterday when we are all very crowded and we have had a very busy schedule. And also my colleagues from the technical department, Lorena, Bianca, Stefan and Octavian, for all the help provided these days. I think we are all ready and we can pass to Professor Sârbu.